Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Benedict, I'm Community Manager here at WeAreDevelopers and I'm glad that you all joined us today. So today's all about .NET and we have 4 awesome speakers today, but before we start with the first talk, just some quick informations. First, don't forget tomorrow is the InfoBit Connect in Berlin as an in-person meetup actually. So if you're based in Berlin, check it out via the link in the video description or in the chat. And this is actually a part of our pre-events for the World Congress, for the WeAreDevelopers World Congress, which takes place also in Berlin, but end of July. To get further information on that and claim your tickets, we made it very easy for you for the landing page. Just click the banner above the stream and you're good to go, as it links to worldcongress.dev. And now, before we start with the talks, feel free during the talks to interact with the chat to your right. If you got any questions, submit them via the blue Ask button. But as always, be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And let's get started with .NET. The first speaker of the day is CEO and co-founder at Software Architects. He writes books and articles on software architecture, databases, and .NET development, is a Microsoft MVP, and he likes to speak at conferences such as ours today. Welcome, Rainer.
Hello, Benedict. I'm super glad to be here.
Rainer, and we are glad to have you today. Thanks so much for joining. Before we start with the talk, would you mind sharing with the audience and me a bit about what we are going to learn from you today?
Absolutely. We are going to have a little bit of fun by building a small game. And during the game development, I'm going to show you a bunch of tricks, hopefully interesting tricks that come from latest versions of C# and .NET. So not just a Hello World sample, but learning C# by building a funny game.
Rainer, sounds awesome. You got my full attention, and I bet that from the audience as well. And I would say without further ado, the stages are yours.
That sounds great. Thank you very much, Benedict. I'm super happy to be here and to have the chance to spend 3/4 of an hour or so with this simple sample. I, of course, offer the source code on GitHub. So I think the organizers will post the link to the GitHub repository just now or in the next few minutes. So if you would like to follow along, you can do so. But I recommend just watching my demos. And if that looks interesting to you, maybe you can take a look at the source code later on. So what are we going to build? We are going to build a so-called isometric game. If you are a little bit into game development, you know that isometric games are games which are kind of looking 3D, but they are not really 3D. They are just simulated 3D elements. And the game can't be too fancy because we only have limited amount of time and our primary goal is to learn C#, not to build the greatest game on earth, but still, hopefully, it will be a funny morning together. So let's jump right into it and let's get started. I prepared a very simple application, C# application. Obviously, if we take a look, it's already on the latest preview of .NET 8, and I'm going to use Visual Studio Code today. No Visual Studio? Well, I think I will start with Visual Studio just for a brief moment, but most of the time I will stay in Visual Studio Code because I like this lightweight development environment very much. So now let's take a look at the configuration of our tiny little app. As I said, it's using .NET 8, the latest preview of the .NET world, if you want. Of course, we are using implicit using, so we do not have to write things like using system link, and so on. They are just magically there. I hope you all know this feature already. Then, of course, we are going to build nullable-enabled code. That is something that you definitely should check out if you don't write nullable-enabled code yet. It's super useful. It will reduce the number of unhandled exceptions, of null reference exceptions at runtime to a great degree. You should definitely try or strive for building warning-free nullable-enabled code. Last but not least, The game will run in a desktop app. I'm going to use the WPF framework, but we are not going to use a lot of WPF. You could build the same game using WinForms or any other UI technology. I just need a graphical window, and I happen to know WPF pretty well, so I just used it. The main part, the main job, the heavy lifting is done by a framework which is called Skia. Skia is the rendering engine that you might know from the Chromium browser. It's the thingy in the background which is super efficient and draws all the different pixels on the screen. This is what Skia can do very, very well. And there is a nice little wrapper around Skia, which is called Skia Sharp, and you can just take it and throw a WPF control, in my case, on the screen, and it will beautifully render all your images on the screen. So if you need to do 2D imaging, then you definitely should check out Skia Sharp. Last but not least, I have prepared a bunch of game assets. To be more specific, I have, here it is. I have prepared a sprite sheet. Now, if you're not that much into game development, sprite sheets are big images where you can combine multiple small images in a larger one. Well, when building a desktop app, we don't really absolutely need this big sprite sheet, but I want to demonstrate some C# features, and therefore I combined all these things. Let me show you how this looks like. This will be our player, and there you have a bunch of different platforms which we can use to build our nice little isometric game. Some have greens, some are icy, some are more, let's say, Halloween style. You see it here, and they are just in this huge PNG where all our game assets are combined. This is what we have prepared. And with that, without any further ado, we are going to jump right into it, and we are going to build our game. The first thing that we need is we need a game window. So let's create a game window.c# here, a new class, a new file to be more specific. And of course, I have prepared the code because in 45 minutes, I have no chance of writing all this code. This is how this demo will work. I will paste in a bit of code, and then we'll do a code walkthrough, and I present to you in practice, in practical, small, little, tiny chunks, new features of C#, latest C# language, and .NET, of course. Let me paste in a few dozen lines of code, and let me demonstrate what we are doing here. Well, the very beginning here is pretty obvious. I just create a record. If you're not familiar with records, you should definitely check them out. I will not go into details here because I don't have the time today, but records are super useful. And in this case, I create a record which holds a bunch of function references. Actions which can draw something on the screen, as you can see here, which can handle some user interaction like key down, mouse up, and so on. It's just a collection of callbacks that our window can call into our game logic in order to do something, to draw something on the screen or interact with our game. Nothing fancy here. Next, we have a game application, which just derives from WPF application. Again, nothing specifically interesting here. The only thing that we have here is we take these handlers as parameters to a static factory function, which can just say game application.run. I give the handlers, and then the game starts running. And inside of this function, we have the first interesting aspect that I would like to point out. As you can see here, I'm checking for null in the parameters handler. I see a lot when I work with customers, still people work writing if blah, blah, blah equals null, then throw new argument null exception. You shouldn't do that anymore. C# had originally planned for the latest version a specific operator, the double exclamation mark operator for automatic null checking. But this feature was dropped after the community did not react very well to this proposal. And therefore, we are back to .NET 6. But still, I see a lot of people not using this feature already. Argument null exception .throw if null. This is the best way of checking for null in a function. Try to remember that, it's super useful. The rest is just WPF stuff. If you're not that familiar with it, we need to set the threading model, but yeah, nothing special here. Last but not least, we create the game application, and the game application will create a new main window. And here it becomes interesting again, because here we see again new features, brand new features, which came in C# 11. And the important thing is this guy here, file, you see? These are so-called file scoped types. In this case, I don't want to make the game window available outside of this gamewindow.cs file. And therefore, I can use a new modifier, file, and that restricts the visibility of the game window class to exactly that file. In the background, the name of the class is changed in a way that is not known to anybody outside of this file. So therefore, you cannot reference this type outside of this file. I use this file scope type here in this example in two places. First, for our game window, and secondly, for a points extension class, because again, something that many people are not aware of, I wanted to showcase here a feature which is not so new, but many people simply don't know it. You can add with a static class and an extension method. Do you see the extension method here? You can add so-called deconstructors to external classes. I guess, as many of you are C# pros here in the audience, you know what extension methods are. You might know what a deconstructor is, but did you know that you can add an extension method acting as a deconstructor? That works perfectly well, and I combined this feature with the file scoped type here to add this extension deconstructor only inside of this file. And by adding this small little helper, I can scroll down a little bit, I can write something like this. And this is super, super nice. I get back a point structure, a Windows point structure, and I deconstruct it into two separate variables, x and y, which immediately have the correct type. And with that, I can call our handler, which will do the heavy lifting for, in this case, mouse down, for instance. So you see a nice combination of a brand new feature, file scope type, with a feature which is rather kind of new-ish, let's say it like that, deconstructors and extension methods. Well, extension methods are not that new, but new things are coming in .NET 8, but this is a little bit too early to talk about. We will hear more about that in summer and autumn. Let's put it like that. Okay, so we have our game window here, and this game window is pretty simple. You see, what I do here is I create a regular WPF window. I add some handler functions, as you can see it here, the close handler, the key down, the mouse down, and so on. And last but not least, there is only a single control in our Windows window here, and that's simply the Skia element. That's simply the element that displays pixels on the screen using the Skia framework, which, as I said, comes from the Chromium project. Scroll down, 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 a lot of event handling, and down here, we have our draw loop. As you can see, what I do here, very simple. I start a timer, and every bunch of milliseconds, I invalidate the visual, meaning I tell Skia, update the image. Now, don't get me wrong, this is not a game engine, by far not. The purpose of this talk is not to build the best game with the most efficient algorithm on earth. This is not the goal of this talk. We just want to learn about new C# features, and we want to have fun by building a tiny little game. So this is a kind of minimalistic display or gaming framework, which we just spin up with a bunch of lines in C#. That's the goal here. So don't expect this to be a competitor for, I don't know, some large game engines out there. Absolutely not. It's just a minimalistic way of having a little bit fun with C#. Okay, so this is our game window. Now that we have the game window, we can see whether we can display this game window on the screen. So let's take the program.cs and replace it with just a few lines of code. Here you see this calls our application, gives in a bunch of functions, as you can see them here, and believe it or not, we have two very interesting new C# features here in action. The first one is, again, not that new, top-level statements. There is no main method, there is no program, class, something like this. I immediately start coding in program.cs. You know this programming style probably from ASP.NET Core, but this small little demo shows you that this is possible with WPF or WinForms or whatever you do too. This is not specific to web development. I really like that one, especially when I do educational coding, where I would like to focus on some algorithmic stuff. I don't want to bloat my code with a lot of unnecessary classes and a main function, which I do not really need in this application. And therefore, I like top-level statements. And the next interesting thing here is that we can immediately pass in here the functions, although if we take a look at the game window up here, we have actions and funcs here. We don't need to new up a func delegate or an action delegate. What we have here are the so-called natural types. This is also a rather new feature in C#, that if something receives a func or an action, we can immediately pass in the name of the function, and everything is fine. C# can do the heavy lifting, can do the type conversion, whatever you need. So let's give it a try. Let's run this app. I'll press F5 to start the debugger, and let's see if everything works fine. A window should come up just in a few more moments. And here we are. This is not the correct one. I'm very sorry. I have to clean up. Of course, I tried it before I did this session. And unfortunately, the result was cached. So let me run it again. So let's see, we have here maybe in launch JSON, maybe something, let's see, something goes on here in bin and debug. And now, oh, you see, this was the mistake. I didn't fix the .NET version here in my launch.json. This is live coding. I promised you, no slides, just code. This happens if you do live coding. So let's run it again. And here we are. We have an empty window. This is exactly what we wanted. And inside of this empty window, we want to draw our little game. Okay, this is what we are going to do next. But of course, the goal is not just to make it as efficient as possible. We want to learn about new things in C#, and therefore I will make us jump through a bunch of hoops in order to learn interesting things about C#. Now, in order for you to understand what's going on, I want to introduce you to a tool which I regularly use when doing educational coding, creative coding, something like this. It's a spreadsheet packer. Now, what is a spreadsheet? You can essentially drag and drop images onto this packer, and it will create a large PNG file for you. So what it will do, it will essentially create something like this. But in addition to just creating here this image, you can also download a JSON file which describes the different images. Where are they in the spreadsheet? How large are they, width and height, and things like that. I downloaded that JSON file already for you, and let me show you this JSON file. You see there is a frames array, and inside of this frames array, I have a single object which represents a single tile inside of our spreadsheet. And here we have the original file name. We have the different frame coordinates. This one happens to be on coordinate 0, 0 and has a width of 264 pixels. I think you understand the rest. And yeah, I think it makes it pretty obvious, right? Now, this JSON is pretty long. It's 4,400 lines long. And in real life, you would probably translate this data structure into something that C# can immediately understand. But we want to really parse this JSON. Not because it's efficient, but because I can demonstrate some interesting stuff here. So let's take this JSON and let's see how we can parse it. And I will show you a bunch of interesting features from the latest version of .NET when we parse this file. I will do that by copying here, by copying one file into our program, and I will immediately walk you through the code. Now, this thing contains a struct which is called a spreadsheet data, as you can see it here. And this is a so-called ref struct. If you're not familiar with ref structs, you should definitely check them out. Read-only span, or in general, spans memory. No, not memory, but span. They are ref structs. Ref structs are simply data structures which must live on the stack. And I just wanted to remind everybody that they are there. And maybe some of you don't know what ref structs are. Take this as a kind of homework from this small little demo and refresh your knowledge about ref structs. They are super useful. Now, inside of this ref struct, I have this frames JSON, and here interesting thing is going on. As you can see, this string literal, in fact, it's not a string literal. We'll come to that in a second. This literal starts with 3 double quotes. And this is a brand new feature of C#. It's the so-called raw string literal features. Essentially, what you say is you say, hey, C#, here a string literal starts, and the string literal ends when you see another 3 double quotes, as you can see it here. And the beautiful thing here with these new raw string literals is that C# will remove all the unnecessary white spaces. So that means the first carriage return line feed or just line feed here is ignored. It's not part of the string. This unnecessary white spaces here on the left is simply ignored. They are not part of the string. Otherwise, the string wouldn't look beautifully if you print it. And again, the last carriage return line feed or line feed, depending on your settings, is also ignored. So you will really get a nice trimmed version of the string, and that's super useful. Additionally, Visual Studio is even smarter than Visual Studio Code when it comes to new raw string literals. Let me show you what I mean with that. I will quickly open this up in Visual Studio. This is the latest preview. I updated it today in the morning, so it's already ready for .NET 8. And hopefully, if nothing crashes, we will open up the file, and I will open up the sprite sheet data file for you. Now, this is Visual Studio, not Visual Studio Code, and look what's happening. See that one? We have syntax highlighting for JSON. So Visual Studio automatically recognizes some raw string literals and colors your code according to what it detects, in this case, JSON. So if I screw up, for instance, something like this, it's no longer JSON, and I see that immediately as a coder because I don't have the correct color coding here. See? So this is useful when you code in Visual Studio. However, I like the lightness of Visual Studio Code, so I will go back to Visual Studio Code, although I don't have this nice little syntax highlighting here. Maybe it will come later, I don't know, and I don't care for the moment, but I wanted to show you this brand new feature of C#11. Now, at the end, we also see something pretty interesting here. We see something new. We see that we have a postfix which says U8. U8 like an unsigned 8-bit, meaning a byte. What does this postfix mean? This is again brand new in C#11. It allows you to specify not Unicode string literals, but it allows you to specify UTF-8 encoded byte arrays, or in this case, a byte span. It's just a span here. So this is really useful because if you take a look at this code is not really code doesn't have a lot of emojis or special characters in it. So we can save a lot of memory by just not using 2 bytes per character, but using a single byte per character and doing UTF-8. At the end of the day, the JSON parser immediately processes UTF-8 out of the box, so there is no need to translate this literal from UTF-8 into UTF-16 Unicode with all these things. It's simply not necessary. This is, of course, particularly interesting when you do web development, for instance, and you get an UTF-8 payload from a request or have to build something in a response. C# has learned a lot of new tricks when it comes to string literals and UTF-8 encoding. So definitely check that out. A nice combination of new raw string literals and UTF-8 string literals. So we have JSON in our app. Now we need to parse it. Okay, let's go on and parse this thing. Let me see what I need to do before we do that. I have my my notes here on my second monitor. We already checked that. Here we are. Yeah, sprite sheets. And what else? Key extension and player. Exactly. These are the three files that we will go on next. I will not talk about Skia extensions. Let me show you quickly. It's just a helper function making it easier to draw a centered bitmap. Very simple Skia algorithm going on. Not interesting for a talk. Same here with player. It's just a helper class representing the player, where the player knows where it currently is, how large it is, and it contains a bunch of very, very simple helper functions, drawing the player, the nice little penguin on the screen. Not interesting for today's demo. However, Spritesheet CS, that is interesting for today's demo. In order to show you what's going on here, I would like to put the JSON and the C# files side by side so you see the important things that I would like to point out here. The first thing that you see is that we often, inside of our JSON file, we often have this combination of a coordinate X and Y and a width and a height. Obviously, we could create a record or a class in order to deserialize something like this. Absolutely no problem. But you know what? In Skia, there is a specific data type which is called SKRect, as you can see it here. And there is also a data type SKSize, and there is also a data type SKPoint. And what I really want to do is I would like to deserialize something like this directly into something like an SKRect, for instance. But that's a problem because SKRect has a little bit, has other properties. They are called width and height, and X and Y need to be translated to uppercase characters. So what we essentially would need to do is we would need to add some JSON attributes on top of SKRect, but we don't own SKRect. SKRect is something that comes from the Skia framework, so I have no chance of manipulating it. So do we really need to deserialize such a data structure into a helper object, filling up our precious heap, giving a lot of work to the garbage collector, and just to translate that into SKRect data structures? No, we don't, because C#11 learned new tricks. Let me show you that. In C#11, we could very easily, that's not absolutely new, but it's kind of new, we can very easily create so-called JSON converters. Probably you are aware of JSON converters. What they essentially do is you have to provide a read and or write function that is capable of deserializing or serializing a certain data item, in this case SKRect, from a given low-level UTF-8 JSON reader. So we take the UTF-8 data that you saw before, and we simply parse it using some low-level functions from the reader. We can check token types, we can read the different tokens, token by token, we can get the attributes and properties from this token and things like that. So as you can see here, we are just parsing this X, Y, W, and H thingy here. And at the end, we create an SKRect. So this converter is nice, but how should we apply the necessary attributes so that the JSON deserializer knows that it needs to apply this file scoped, remember it here, another C# feature, we talked about it, this file scoped converter. As I said, I cannot change the code of SKRect. And here we have something brand new. When we deserialize JSON, as you can see it here, we can specify JSON serializer options. And the new thing here in .NET 7 is the so-called JSON type info resolver construct technique here. We can specify a method, as you can see it here, and inside of this method, we can write code and change the way that the JSON serializer will deserialize the data. And in my case, I can walk through all the properties of all my classes and find out where I have an SKRect and add the converter without having to manipulate the code of SKRect. So I can externally wrap a JSON converter around an existing type. And I can do a lot of other things. If you, for instance, say, all the attributes or the properties in a certain data structure that fulfill the certain characteristics, maybe naming characteristics, data type characteristics, they should all behave the same. And you do not want to manually add some JSON deserialization attributes on top of it. You don't need to do that any longer. What you can essentially do, you can apply or provide such a default JSON type info resolver method, and then you can programmatically change the attributes which control the deserialization and serialization of the whole JSON. And that's the point here. You should remember this JSON type info resolver thing. I have added a link here. You can take a look at this blog article to learn more, to learn all the different possibilities that you have here. .NET 7 has more functionality in its toolbox for serializing and deserializing JSON, but I have limited time today, so I only can talk about this one. I hope it was nevertheless interesting and you saw that this is really, really useful. The rest of this file is just applying exactly the same thing again, but for some additional types. So I will not walk you through again because I would need to repeat myself and that's kind of boring and a waste of time. So let's close this one and let's just accept that we can now deserialize the JSON just as we need it. Very nice. Now, do you want to see something on the screen? I can't await it anymore. So we need to go into Program CS and draw something on the screen. Now, I have prepared a rudimentary implementation of our drawing logic. It's just a few dozen lines of code, and I will show you that in a second. First, we have some constants which define some behavior of our game, how large are the different tiles and so on. What is the side length? How many tiles do we want to have? With tiles, I mean these nice little thingies here. These are tiles, see? Then we are parsing, see? We are parsing the JSON. We are loading the image from the resources of WPF. You can, after my talk, you can go into the details by taking a look at the code in GitHub. And then what else do? We find out the size of the different sprites by reading the width and the height. Nothing special here. We initialize and create a player. And then we have a very simple draw function, which simply does some translation magic, meaning it shifts the viewport. It does some scaling magic. If we would like to zoom in, zoom out, very simple. Skia does all the magic for us. We simply need to tell it where it should shift the viewport, where it should apply some scaling. The rest is done automatically. And then I simply, here you see it, call the draw method on the player. So nothing special, nothing fancy going on here. And down here, we see the different event handlers. There are a few interesting things, but the most important things will come in a minute. But this is one that I see many people struggling with. It's not a very new function, but still it's a kind of heavy discussion going on between C# developers. I mean this structure here. A new operator without the data type behind it. C# can infer the data type that is necessary here by taking a look at the surrounding code. And in this case, I would like to create different versions of coordinate movements, either in X or Y direction, -1 or +1. I think you understand the code if you know that we need to move around our small little penguin on the screen here. And here I think is a really nice application of putting the data type on the left-hand side of the variable declaration and then omitting the data type on the right-hand side in the switch expression that I use here. Otherwise, I would need to write new sk point I, new sk point I, new sk point I. I think you got the point, yeah? So many people struggle with that. I see people and teams discussing about var, and they discuss about that one, and they simply don't like this omitting of types. I personally really think it can enhance the readability of your code in certain situations. And this is a situation where it is really nice to put the data type on the left-hand side and omit the data type on the right-hand side of the equal sign. And the rest, nothing special. I think we can give it a try, run it and see whether I screwed up. Let's see. Run it. And give me a window, please. Yeah, here is our penguin. I can go down and right and up and left, and I can even change the viewport. You see, I can move it around with the mouse. I can zoom in. May I introduce the penguin? So this works really nice. We already managed to parse the JSON correctly. Otherwise, we couldn't display the penguin, which was cut out from the spreadsheet. Where is the black penguin? I can't find the black penguin. It needs to be somewhere here. I'm pretty sure it is here. Otherwise, I couldn't find it. But here you see the other penguins, yeah, the other colors. I think you get the point, okay? So you see, we are already pretty far in our demo. The last thing, let me check the time. Okay, I have 15 minutes or something like this left. The last thing that I would like to do is I would like to deal with these tiles. I would like to create a beautiful background for our game and then take a look at some additional new features. Now, let's pass in or add a new file here that will care for the tiles in the background. Now, what does that do? The first class is really not interesting. It just contains a bunch of metadata about our tiles. You can see I take the file names and I characterize them, whether they are of type snow or whether they are kind of green, grass, something like this, whether they are a bridge. Let me show you the bridges. Where are the bridges? Here is, for instance, a bridge. See that one? That is a bridge. We can add that too to our nice little game, whether it is of the dark color for Halloween theme or something like this. I just added a bunch of metadata here to make it a little bit more interesting. Now, here I have one interesting thing, which is, again, not super new. It came with .NET 6, but still I see many people not doing it. Do all of you know random.shared? This is very useful when it comes to random numbers. And sometimes you need random numbers, right? If you're building games, you need them all over the place. But even if you build business apps, maybe you do some Monte Carlo simulation or whatever, then you need random numbers. And many people still use new random and then call next. But this is no longer necessary. If you want to have a thread save random number generator, you do not need to new up an object and put pressure on the garbage collector. You can simply say random.shared. So remember that. It's a small thingy, but I see in my work as a trainer, as a coach, I see many people not using that already, and you definitely should. Now let's scroll down a little bit just to refresh my memory if something is interesting here. Okay, we will jump into this parsing in a second. What else do we have? Yeah, this is something which is kind of interesting and new. It's a tiny little thing, but still it is useful. Please note that I'm using a string interpolation here. And inside of the string interpolation, you have the curly brace here and the closing curly brace here. And the new thing is that we can now have multi-line string interpolations. So if you want to, for instance, add some documentation, or if you have a link statement and you would like to split this link statement up into multiple lines, but it is part of a string interpolation, you can now do that. That is possible in C#11. You can simply open the curly braces on another line, then closing the curly braces. The rest is just a little bit of business logic that we need. You see just 200 lines of code. We will dive into the parsing a little bit later, but that's it. I don't need to go into all this code. You can take a look later on. I would like to go back to our program CS because now the interesting thing, the highlight of my talk is coming because I really want to paint a beautiful background here. So what I have prepared for you is very simple. Let me go here and copy a little bit in here. We need a game board. This is our game board. And we need to enhance our drawing logic a little bit. Here we are. Good. So what we now have here is we have a tile array, a two-dimensional tile array. And for demo purposes, I will just fill it with the Arctic 15 tile. You will see in a second what this Arctic 15 tile is. And the enhancement of the drawing here does nothing else than simply draw each tile. See, that is the only thing that I added here. Let me show you what that has, what the result of that is, and then we will spend the final 10 minutes exploring some link enhancements in C#11. See, that is our nice little game board. I can zoom in, I can zoom out, and I can make the penguin hopping around on this nice icy little area here. And this is just this tile thing. So you see, works perfectly fine just as we want it. Very, very simple. Of course, we could change this one. I have no idea what Arctic 14 is. I can't remember. Let's simply run it so you get the point. What we do here, we simply take the, you see, it's an icy thing with some cracks in it. Okay, that is fine. And now I think you get the point. That's an isometric game area. It looks a little bit three-dimensional. When we add additional tiles, you will see it even better. But essentially, it's a 2D game. Okay, that's it. You can take a look at it afterwards. So what can we do? How can we have a little bit of fun with for the rest of the talk? Let's create a row helper variable here, and then try to play a little bit around with this helper thing. The first thing is we will add in a for loop some random rows. We have to build these random rows. The random rows will just generate a lot of random tile combinations based on a theme. Take the Arctic theme here. It just goes through and takes 10,000 random numbers and then selects random tiles and adds them to our game. Of course, in reality, you would not create 10,000 instances of tiles and then pick randomly a bunch of them for your game. But for demonstration purposes, please bear with me. We are going to dive into some link enhancements in a second. But let me quickly show you what these few lines, these random tiles did to our game. Let's run it, okay? So this is just adding random tiles, and now it looks much more beautiful. We can walk through, and you see I built a bunch of Easter eggs here. Whenever we collect such a numeric decorator here, boop, our penguin gets a new color. Isn't that nice? Now I can show you all the different penguin colors that I have for you, and the penguin can also not walk over these empty tiles here. So you see, it works pretty nice. We can zoom in, zoom out. It works just like a charm. But this is not a new thing in C#. What else can we do? Let me point out again what these random rows are. Just for demonstration purposes, I generate 10,000 combinations of 10 tiles and store them in random rows. And now I can do something like that. This is, that. What is that? This line is pretty interesting because it contains something which is brand new in the latest version of C#. Please check that we select here using link something from our random rows. But this link query is using something very special. I will mark it here using this yellow rectangle. It's using a list pattern. A list pattern means that take a look at all the randomly generated tile combinations and select one where the first tile is not empty, you see? So I can specify a pattern inside of a list in order to select something from a collection. In this case, I'm saying take only a random row that has an empty tile at the beginning, no tree standing there or not being a bridge, something like this, just an empty tile, and it must not have a decoration. A decoration might be such a number item, or as I said, a tree or something like this. The beautiful thing here is that I can define recursive patterns on top of collections and then use a link statement to find specific collections, meaning collections that adhere to certain requirements. So in this case, give me one that has an empty tile at the beginning with no decoration. And then I can add more and more of these link statements. Let me show you a bunch of additional demos here. I can, for instance, say, give me a random row. You can see it here. Here it is, where the first one is definitely not a bridge. And the second one must be an empty tile, completely empty. Here you see it. Then we say the first one should not be a bridge, but the next one should be a bridge. And then I don't want to have a bridge again. Then I want to have as many other elements that I want. And at the end, I want to make sure that I don't have a bridge again. I think you get the idea now. You define a pattern, and with that, you filter on a list, on a collection, for instance. And let me quickly show you how that works. I will run it. And hopefully, we will be able to see exactly that. Yep, I think that is good. You see, let's take a look at the third line here. We say here, oops, wrong zooming, now correct. No bridge, no bridge. Then we want to have a bridge. Here is the bridge. Then we want to have no bridge. Here we have no bridge, and so on and so on. I think you got the idea, right? So these are list patterns, and they are a brand new enhancement for link. And you can do that, and you can apply this in a lot of situations. And inside of these list patterns, you can use additional pattern magic. So in this case, I'm using a property pattern. I'm using a constant pattern. All these things are applicable here. So I hope that makes it somewhat clear what's going on here. And last but not least, I would like to be able to do something like that, to specify, to act as a kind of level designer, as you can see it here. Now, this parse method is a method that I would like to add, but let me quickly tell you a little bit about the scenario here. As a level designer, I don't want to have random tile combinations. I want to say the first tile should be Arctic 2, then again Arctic 2, then Arctic 3, then Arctic 4, then Arctic 14. I think you get the idea, right? We need to parse this string. Now, how can we parse this string? We can simply split it up and then use a little bit of parsing magic to convert that into a file name. But the interesting thing that we see here in this parse method, that this parse method is not specifically implemented for tiles. Instead, it's using a brand new interface, which came just in the latest version of .NET, iParsable. This is a generic parse method which can essentially parse anything where the values are separated with a blank. So what it does, the business logic is split it up using a blank and then call the parse method on whatever type we have. I can parse a blank separated list of numbers, of date times, of whatever I want. That's the idea here. The ability to implement generic algorithms working on top of data types which are parsable. And this is enabled by the brand new interface iParsable. Now, what did I have to do in the tile class in order to make this thing parsable? Let's take a look. First, I need to derive from iParsable and optionally from iSpan parsable. Depends on whether I just want to be able to parse strings or whether I want to be able to parse spans. Now, the implementation is pretty straightforward. Here you see, this is my try parse thing. What I essentially do, I take a look at the first letter, which can be W for winter theme, A for Arctic theme, or H for Halloween theme. I'm just picking some different tiles here. And the interesting thing here is that I'm using, again, see, a list pattern to parse a string. I view the string as a collection of characters, and I say, if the first character is a W, then I would like to get by number a tile from the winter theme, and then I take everything which comes after the W and use it for an int parse. Let me refresh your memory, something like this. So A14 would be parsed by applying a list pattern here, going into this arm of the switch expression here, removing the a, storing the rest of the string in this variable num, and then I parse this num, and I don't have to apply some regular expressions or doing some string operations. It works really nice by using, again, these list patterns. So you see, you can now generate and write your own data types, which are generically parsable, and then you can write generic algorithms that can deal with anything that can be parsed. And as you saw, list patterns are super, super useful. Do you want to see? Do you want to see our final game? Let's run the game again and let's check it out if it works. And here is our nice little penguin. You see, it can walk around. It works perfectly fine. And I can now tweak it a little bit. Maybe we change Arctic to, for instance, Halloween, something like this. So you really see that this stuff works. It's selecting random values. And you see now the theme has changed a little bit. We can zoom out so you see everything. This is the parse thing with the iParsable and so on. I hope you got the idea here, and you saw what is possible. So this is what I wanted to show you. This was the goal of my session today. I wanted to show you a bunch of interesting C# features by implementing a small little game. And I think we succeeded. At the end, I can just invite you to maybe ask a bunch of questions if you want. Get in contact with me. We can link each other on LinkedIn, or you can take a look at my YouTube channel or whatever you want. And finally, I invite you to take a closer look at the entire code base, which is, as I said, available on GitHub, and the organizers will definitely share the GitHub link with you. Thank you very much. And I guess that Benedict will now join me on the stage again. Am I right?
Yes, Rainer, thanks for announcing me as well. And thank you for the awesome showcase. I really enjoyed it, and also you got get a lot of love in the chat. Awesome talk.
I love that.
Finally, a talk about creating games. Love this. So really, really. Also some German viewers here. Vielen Dank, Rainer. Super gemacht.
Dankeschön.
All right.
Do we have any questions from your side, Benedict, or from the audience?
You already teased it. Maybe let's start with one question about the features. We got one, as your talk is about latest features. Which features do you still miss in .NET or C#?
Oh, that is a hard one. That is a really hard question. Which features do I miss? Well, there are some very interesting features coming in the next version of C#. What I find particularly hard for beginners, whenever I do training, I also teach students at the vocational college. I'm a mentor at the local Coder Dojo, so I have to deal a lot with kids and young people who learn how to code. And in C#, it is particularly hard for them to understand the concept of extension methods. As a very old coder, I know where extension methods came from, and I know why they are widely used in frameworks like ASP.NET Core in order to make your applications modular. I understand the reasoning behind it, but it's very hard as a beginner who doesn't have the knowledge about the history of C# to understand why you need these extension methods. And I'm super, super glad that we get new features in the upcoming version of C# that make it easier to understand extension methods, that make it easier to write extensions for existing classes. C# gets rid over the mid to long term of this kind of clumsy this extension method syntax, and we get a first citizen syntax construct for extending things, for building extensions. If you haven't taken a look at, I highly recommend to maybe Google for C# feature status page and take a look at the proposal for extensions. I really hope they make it into the next version of C#, because I think then C# will be easier to use, especially for beginners.
Well, thank you for that very, very awesome answer also, and for taking your time to answer it that long. And
Absolutely.
let's go on to the next question. Have you also worked on bigger games or community mods for existing games?
I'm not a professional game developer, absolutely not. But I just told you that I do a lot of teaching. I have been in the teaching world for more than 25 years. I mostly teach professional developers in C Sharp, Rust, Go, and TypeScript. These are my 4 languages that I regularly use. But as I said, I work a lot with young coders and kids. And especially when you work with young coders and kids, you must not do samples which are just technically or print hello world on the screen. There has to be a lot going on the screen. And this is exactly where I use games. Children and young people love to write games. But as I said, I'm not a professional developer. I mainly use very lightweight gaming engines, especially in the JavaScript world, gaming engines like Phaser, P5.js, or Excalibur. This is what I primarily use, and you can only build very simple browser games with them. But for me, for my purpose, where this is primarily a teaching tool, they are perfect. I don't need Unity or something like this in order to teach a programming language. I just want to make it fun. And these simple gaming engines does exactly that. They do a great job in that.
Yeah, I can totally understand what you mean by that. We also started when I went to university with like some quick fun games, and we did this in processing, for example, which was
Yeah,
also very, very
P5.js, I
exciting
just
too.
mentioned it. P5.js is the JavaScript clone of processing. So I'm not a Java person, but I love JavaScript and TypeScript. So therefore, I use P5.js, but the API is essentially the same as processing.
All right, nice. Thank you for that answer as well. Let's go on to the next question. Maybe we stay at the gaming topic because one of our community members wants to know: do you consider yourself a gamer? If yes, what's your favorite game?
No, I'm not a gamer. The last 2 games that I played, well, the only game that I regularly play is Age of Empires. Why? Because I started it decades ago. And when I need a little bit of relaxing time, I sit down and play a bunch of Age of Empire rounds. But that is really the only game that I do. I enjoy it, to be honest, more to build small little tiny games myself together, as I said, with students. I'm more the convenient game designer and builder than a player on my own. But if I do gaming, I mainly play Age of Empires.
All right, yeah, awesome game. And like it's an evergreen, so I think it will be also
Absolutely.
played in 20 years from now. So
Hopefully.
just a classic. All right, Rainer, let's go on to the next question. What knowledge do I need to do something like you did in your demo?
What knowledge do you need? You need to have at least basic knowledge about Windows desktop development. So you need to have basic knowledge about WinForms, Avalonia, WPF, or something where Skia runs. You need to have basic knowledge about Skia. So you should definitely read the documentation a little bit. And then you need a lot of creativity. I didn't draw the images, by the way. If you want to build such simple games and you are not a designer like I am, you can take a look at platforms like for instance, CraftPix. My images were from CraftPix. They offer a lot of free images, and also the commercial images for game development are not that expensive, so it's okay to download maybe one gaming kit. I take a lot of images from there. So you need the game assets, you need a little bit of understanding of the surrounding system, and then you need a lot of creativity. And then you can start. And the beauty of today, I really find this amazing, is that everybody can start coding independent of whether you are in a school which dedicates itself to teaching coding, because you have one of the best tutors available for free, and that's ChatGPT. Really, ChatGPT is revolutionizing the way that people learn coding. And I highly encourage you to just fire up ChatGPT and maybe take my code, copy it in there and ask ChatGPT, describe this code. and you will definitely get a nice description. So if you are new to coding, use generative AI in order to learn and understand code, and also let this thing teach you in the basics. You have to learn a lot, and ChatGPT is not perfect, but it helps a lot getting started.
Yeah, we actually talked a lot with also other speakers on our past few live days about ChatGPT and many different views. But where we all agree is, yeah, it's a thing for the future. It will stay, and we need to adapt it to us.
Absolutely.
So yeah, Rainer, thank you so much for the awesome talk. Thank you also for taking time for the Q&A. If you, to the audience, if you have some questions left, we will post Rainer's website where you can find his socials. Feel free to reach out to him. He will gladly answer your questions. And yeah, to you, Rainer, thank you so much for joining us today, and hopefully see you on another live day. Bye.
See you. Bye.
And before we go on to the next speaker of the day, just a quick 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Before we go on to the next speaker, just real quick, as the question just came in, if the recording will be available afterwards. Yes, right after the live day, you can watch it on demand on our landing page the whole day for the next week. So no worries if you missed anything. And now to the next speaker of the day. He is solutions architect at Smapiot. He focuses on scalable and innovative architecture, is also a Microsoft MVP, and he writes blogs and articles for popular magazines and websites. Welcome, Florian.
Hello, welcome everyone.
Hello, Florian. Thank you so much for joining us today. So happy to have you. So before we start with your talk, would you mind sharing with the audience and me a bit what we are going to learn from you today?
Sure, absolutely. Well, today I will talk about micro frontends and also how we can use micro frontends with Blazor. For those who don't know micro frontends, this will be the right talk for you, right?
All right, then it's definitely the right talk for me. And so I would say, without further ado, Florian, the stage is all yours.
Thanks a lot, much appreciated. Well, before we dive into the topic, already much said about my person. One thing to also note, I did write a lot of articles for various blogs, but I also wrote one book, which is called The Art of Micro Frontends. It's available on Amazon. And if the topic that I present today sounds interesting to you and you want to learn more, this might be a great resource. There are other books I can recommend. Just ask me and I will give you more details. But without further ado, let's just dive right into the topic. And I want to start with a motivating example. Let's take a system architecture as it is done quite often today. And you can guess it already from this picture. You might have seen it. This is a microservice kind of architecture. So you have some services in this diagram indicated by service A, B, and C, which might be publicly facing or user facing. And then you might have some auxiliary services like here indicated by service X and service Y. Why is such an architecture done very often today? Well, of course, it is not always the right choice. And sometimes, well, it is even the wrong choice that you do. But there are clear advantages and you want to gain, of course, these advantages. That's why it's picked very often. If we dive a little bit deeper here, we see that usually these services are scoped around business capabilities. So it's very easy to form teams. And even better, these teams can now autonomously develop their service, which means they have their own development and deployment lifecycle. So if they need to fix something, they just go ahead, they fix it, and they deploy it. So they really own their service, which makes the whole architecture very loosely coupled by definition. And also, there is the possibility of developing services, each with its own technology. That could, of course, lead to some downsides too, but the upside is that if you have a problem that's very well solved with a particular technology, well, the architecture doesn't forbid you to do that. It actually encourages you to use the best technology for the job. And also the teams, of course, are on their own picking the technology set that just fits to solve the problem. So that's really great, and it empowers teams. It scales up development by a major fraction. However, if we continue this diagram and really end in the front end at the user-facing side, well, quite often what you have there is a single front-end solution. And surely there are also reasons for doing it like that. The monolithic architecture usually already provides an integrated and consistent user experience, which is essentially what you want in a front end, right? So you don't want that one button is green, the other is red, and you don't know why. There were all kinds of different design choices there. It should be one consistent user experience. However, there are some downsides with this monolithic approach. So quite often, even though you don't intend it to be like that, it is developed by one central team, which means there is also one release train. So these are usually then larger deployment releases, and very often that leads to, well, what is a feature slowdown at the end, and all the stakeholders are usually not very satisfied with that solution. If they want to have something deployed very quickly, well, they always get some kind of blockers in between. We first need to test this unrelated feature or make sure that the other unrelated thing is working well. And you get all kinds of blockers in the way. So what's the solution there? How can you develop a project like this, for instance? There's a screenshot of the Azure portal. Who doesn't know it? At some earlier stage. And if you ever operated the Azure portal or some other large-scale web portal, you realize that there is, well, first of all, a lot of features in there. But second, if you have ever seen another user operating it, it might look completely different, or at least in parts different for other users. So it's really highly adjustable, and it brings in, let's say, beta features or something only for certain users, were really user specific. So how can you develop something like that that apparently scales very well for the end user, but it must also scale in development, because otherwise, how can a team that is now at Microsoft responsible for this solution really always release it and be on par with their backend services, which, well, are usually quite decoupled and following the architecture we just outlined. And another question that comes up, is this only for teams at companies like Microsoft attractive? Or can other, well, not so software affine teams also create such a solution? And the answer, of course, might be yes, because if you look, for instance, at some German company here that is a leader in the optical sector, they already created such a portal. And what they are able to do is they can really scale it up. And depending on what kind of customer you are, you get a different experience. You get different services in there. And always with new services, this thing is updated very, very fastly. And also, as a side question here, and we will also answer that, of course, just in a few minutes. What if one of these parts that you want to show in there is actually driven by Microsoft's web framework called Blazor, right? So could this software download area that you see here be developed in Blazor, while the rest of the applications may be developed with other technologies? And as you know, the web is already in a constant stream of evolution. So the only constant is change, of course. And if we look back a little bit, we see that we all started, of course, with these really classic monoliths. I mean, I started in the 90s. There, for me, Perl was my language to go to. And it was always single system, right? So we were talking to the web server. It was talking to the database. It was getting some information. It was rendering a page. It was sending back the HTML, and that's it. You got a single system, and it was working well. And everyone did it like that. And also all the big sites that you know today that started in the 90s, like, for instance, Amazon, they started with such an approach, right? You were scaling that, of course, via load balancer. Database was always the bottleneck, but nevertheless, this is how it all worked. But that, of course, changed. And it changed because the web became more dynamic. So users expect a little bit more. I still know when I started using a little application called Google Maps, and when we were just panning around the screen, it was always updating. That was really like a life-changing experience for me. I was really baffled how they did it. There was not a blank page in between. You were just panning around and new tiles were loading, new information was flowing in, and it was kind of a miracle. And the same thing was then applied to other web applications as well. For instance, Gmail in the beginning was a really simple web service, but what made them stand out was actually their web UI, right? So it was clicking on an email, and just the part where the email is displayed was changing. All the rest remained the same, no white page in between, no complete reload. It just worked as you thought it should work, as an application would work. And so the rise of these web applications, in contrast to websites, with the separation of what is now known as a backend and a front end, that really helped to grow us, because now we could have had different backend teams that were creating reusable APIs and front-end team. And even better, with the mobile revolution coming up, I mean, the API in the backend that really was reused was not just reusable, it was reused. But that also provided, of course, another bottleneck, because suddenly we had multiple clients with different teams, of course, but just one backend. And so we needed to scale the backend. And the end result was what is today known as microservices. There have been different approaches in the past too, right? SOAP, for instance, but they always were very rigid, and it was difficult to follow them if you had, let's say, different business goals in mind. And so microservices, which left a lot of things, let's say, to be specified by an architect, they gained, of course, the traction because they didn't dictate you how to do certain things. They just said, well, loose coupling is something you might want to have, and this and that property is something that you want to have. And the end result quite often then looks like outlined here, where you have a gateway, or quite often a backend for front end. And then you have various services sitting behind. And these services then, of course, assume certain let's say, data to be transported in by the gateway. For instance, authentication and authorization, always done potentially by the gateway already, and other things as well. But that is now in the hands of the architect to decide. And this is exactly the picture we've seen in the motivating example where we started with, right? So we have now a backend that is fully scaled up in development, but we have a front-end monolith now for the web, with our potential single page application, or potentially still server-side rendered page, but decoupled, of course, from the data perspective from our data backend. And the next step in this evolution is to do the exact same thing that we did for the backend, also for the front end. And this is now the pattern of microfrontend that comes in. So if you mirror the same thing that we've seen on the backend, what you end up with is an app shell. This is like an aggregation pattern, right? So this can be your HTML page, for instance. And then there are the different micro frontends that are running in this app shell. And that could be as simple as just some web components, but in reality, of course, it will be a little bit more elaborate. And we will see that in a second. But that's the main idea. So we are talking here about a pattern to scale up development needs, to scale up teams, and not a direct pattern, let's say, as an architecture, for instance, what you get solid foundations or some kind of other architectural patterns. This is really about the organization of teams. So it's all about the distribution of work. And following this classic Amazonian approach of what is the 3 pizza team approach. So you could say, well, you have now 3 8-person teams, so 24 persons in total. And that is actually more effective than a 1 24-person team. Well, I mean, I always say, insert the word independent here, because if there's a lot of alignment needed between these teams, well, in my opinion, that might actually be less efficient than just one large team. At the end of the day, it's always about finding the right subdomains. So the whole concept of domain-driven design, all the things that you heard there, that comes back if you want to do microservices correctly, but now also micro frontends, because it's all about how do you now cut your features that you actually can create these independent teams. Great. So how does now a microfrontend architecture look like in real life? Well, let's have a look at our motivating example, just now the user-facing services. How will we now need to design that front-end layer to actually fulfill this promise that we made? That's the most simplistic view on it. So we have our services here, A, B, C, D, and all we do is we place a web server in front of it. And that's it. We are done. Not so fast, of course. This is a picture one, well, very lonely architect might draw in a vacuum. But of course, it leaves a lot of questions unanswered. And these are the questions that in real micro frontend implementations need to be answered. Like, for instance, how can you bring them together? Because consistent user experience is still something you want to have. So let's say our service A is doing billing. It's a billing service, and front-end A, of course, can show you your bills, right? So you get now a list of your bills. You may even get the details of a bill. So you click somewhere, you get now the details. Now, there are a lot of entries in this bill, and you just see some ID. Maybe you see the price where you purchased it, but that's it. You don't see a picture of it. You don't see a description or maybe even the name of the product where you have been billed for. So that's really a pain. Instead, maybe there's just a link, and this link would go now to front-end B, which is the product information service. And that talks to service B to get that information. Now, it would be nice, of course, if in your build details already the details of this product that you purchased are in there. Maybe a picture, maybe the name and the description. So you would need something from front-end B, now in front-end A, to make this whole experience actually what you would expect from a website, right? And this is now where this naive micro-frontend architecture, of course, falls a little bit short. Sure, you can now define, let's use an iframe, for instance. Let's use a web component, whatever you go here for. You could define it here. But again, this picture leaves out all of that. And it also leaves out how these things aggregated. Do you have different URLs? You don't know. So what you could go for is you could actually change that and say, hey, let's propose something. And let's change this maybe to the following picture. Instead of having now individual web servers, server A to D, I have now individual modules, module A to D. And this is now more like what we historically call the plugin pattern or plugin approach. You have now your app shell component, so that's a full application. And this application shell comes with some concerns that are already shared. So for instance, shared libraries are in there, or things like authentication already done here, right? And it also may come already with a pattern library where, for instance, buttons and tables and whatnot are in there to have, let's say, a common design shared with across all these modules. Now, the modules are still independent. So as mentioned, they are like plugins in this picture, but yeah, you would model them around business capabilities. So you would say, great, I have my module A, that's now the billing module. It comes with a component, for instance, for the billing details page. But then if it uses something like product details, it refers back to module B, where product details are contained in there. And this is how you could, let's say, solve this issue of how do the micro frontends come together and how do you make sure that these micro frontends are actually providing a consistent user experience. So far, so good. The one thing that you really need to be aware of is what you don't want to see is a feature overlap. I just described a scenario where you have your billing page, and that uses now a component from your product information micro frontend. And it's quite easy to just introduce strong coupling here to say, hey, I already know that this micro frontend exists, and I already know that it has a component to display me the details of a product, all I need to give it is the ID of a product, and it will give me, it will show the details. But if you do that, and if you just grab it from one microfrontend into the other, if you just do that, you have this feature overlap. And that's what I would always call a hidden monolith. And the hidden monolith is a very, very difficult beast to tame, because at the end of the day, what you create is, with the complexity of a distributed system, a monolith. So you can't just easily do rollbacks of individual modules, because they depend on features of others, and others may depend on features of it, right? And you also can't just easily make a new release of an individual module, because again, it might depend on the feature of another module that is not yet released. And so suddenly you need to have all this alignment in deployments and rollbacks, and that's not the path you want to take. So what you want instead to do is, you always want to do it via loose coupling, and say, I introduce here, for instance, a generic notation for getting some kind of a feature component, but I don't need to know where it comes from and if it's there at all. Because if you do that, that's the same approach as with events. You are suddenly in a loosely coupled area where you say, hey, I just emit this event, or here I just want to render, want to open the possibility of rendering some UI fragment. But if it's not there, nothing bad will happen. And the same, of course, from events, you can just dispatch it. But if there is no listener, you don't care. Same thing you want to introduce here. So don't introduce strong coupling. It introduces, at the end of the day, feature overlaps, and feature overlaps is the death of any distributed application. Right, so now we know a little bit, in theory at least, what microfrontends is all about and what you need to be aware of. Let's have a look how you can implement microfrontends in Blazor. And I will focus on Blazor WebAssembly, but there is, of course, no hard constraint here. You can do most of it that I showed today also with Blazor and server side. And you could, of course, mix with Blazor United, which is coming out soon. Things are usually tend to get more complicated, of course, the more you want to mix things, but it's all possible. Right, so the first approach that you can do is actually what I would call a very, very classical approach, because that's already how we did kind of micro front-ends already 10 years ago, even though it wasn't labeled like that, with ASP.NET MVC and the area feature that it had. So what you could do there is you could just put whole parts of your web application in their own DLLs, and do a discovery of the DLLs and then integrate them or not integrate them. And you can do pretty much the same with Blazor. So what you could do is you just create different Blazor libraries, and so like Razor component libraries, RCLs, right? And then you integrate the RCLs that are found, or you don't integrate them. This way, you can also do that loosely, right? You can discover them, for instance, via whatever mechanism you like, or you can also do it strongly in the case that you know already that a certain library is there. You can just reference it directly, the NuGet package, get the DLL in there, and you know what is available. So the basic idea is you still have your Blazor WebAssembly application that is now your shell, and you can now reference these libraries, as mentioned, strongly or loosely, and create them on the fly, whatever you like to. So how does it look if you say what advantages and disadvantages are there? The advantages that I see are that you always stay in the flow. This is a pure Blazor solution, so there is no need to, let's say, look at any JavaScript directly. It's all C#, it's all Visual Studio. So it's very, very nice solution, especially in teams that are choosing Blazor because they haven't touched any web technologies otherwise. It's always a very difficult path to take, in my opinion, because at the end of the day, Blazor does a lot of web technology under the hood, and in order to really get it, you need to be also in touch with the web technology underneath. But still, it could be a potential, let's say, option to just always stay in C#. The downside is, of course, that these are DLLs. You will always require, especially if you hard couple them, recompilation. Cross-framework support is limited. You can still get them in via web components, but then again, you would touch the JavaScript side. You need to include the JS packages, of course. So yeah, I would say if you really take the advantage of C# all the way, then no cross-framework support is the natural downside of it. And you need this full evaluation before starting anything. That's just how Blazor works, right? So you get the DLLs in and you need to do all the registrations before you start. As an example, the page directive, that's just an attribute. It requires that the DLL has been loaded. Otherwise, it doesn't know that a certain page exists. And that can, of course, be a downside. So lazy loading with Blazor is not much fun yet. But that is, of course, something you can improve with the server-side rendering. Right, so how might that look? Here's a simple example. So very, very simply done. What we do here is we added a new extension method called add library, and there you just reference some component. The important part is that it lies in some other assembly. Again, this is now a hardwired approach. And then it just iterates over all the components it finds. Now, what you can do with the router is you just give it additional assemblies. And so the router gets to know different pages. And otherwise, what you can use is you can register now menu items, for instance, if you consider special notations. In here, we use the Redder fragment, but in general, of course, what you can do is a dynamic component. That's the same thing that just came later. This approach already works with the first versions of Blazor. And as you can see, you can just dynamically create components that you found in some library. And so this is an approach that pretty much always works. I don't want to get into much detail. I will give you the URL of a GitHub repository. You can have a look at the code, just glancing over it very quickly. Right. Now, the downside, as mentioned, is that it is this fully C# approach. And if you take micro frontend seriously, it's all about also allowing potentially other technologies. In general, that doesn't mean you should create a web application that is a patchwork of 10 different frameworks. You could do that, but I wouldn't advise it. But it means that you choose, again, the best technology for the job. And that might not be Blazor, especially when it comes to startup times. And it might be that you actually want to have different, let's say, teams in there that have no experience with Blazor and they want to use their JavaScript things. So how can you combine, let's say, the approach we've seen with JavaScript? Well, one approach is displayed here. Instead of having the application shell written in Blazor, you write it in some other JavaScript-driven technology. Let's say React, but it doesn't need to be. And what you can now do is you can still add the Blazor core libs to this application shell. They are like kind of shared libraries. And you can also go ahead and even put in a design library. What I would advise here then is a design library that's based on web components. The idea here is that while web components might be also a good transport mechanism for micro frontend driven components, they are a great mechanism to bring in atomic components as kind of design tokens. So for instance, a button or a table and all this, because they just work in all the frameworks. So you don't need to, let's say, have your UI library written in like React and Angular and now Blazor. Just have them as web components and they work in all these frameworks. There are, of course, downsides here too, but let's take the design library components as simple as possible, then the downsides are rather minimalistic, if there are any at all. And you get great performance and great reusability out of the box. Now, having said that, you can have a micro frontend like here, micro frontend A written now with React, or another one written with Angular. Again, don't make a patchwork, just for illustration purposes here. And maybe 2 other micro frontends now using Blazor, right? The great advantage is that you get now a really fast startup time. Maybe your application shell is even server-side rendered, and it's even better. And then only the parts that are coming now in, for instance, for micro frontend C or D in this case, they would need to start up Blazor or maybe even load it. Maybe Blazor starts also with the application, but the component doesn't need to render at this point, so there's no DLL loaded for it. And also the user doesn't feel all this, let's say, blockage that usually comes in. So no blocker here because of the delayed startup with Blazor. That just is fully cascaded away in such an approach. Right. Advantages, you can recombine now freely. So doesn't matter where these components are written in. You can now use other frameworks. And that's, in my opinion, the best advantage. You lazy load the Blazor WebAssembly code. On the other hand, of course, that might be rather difficult to do correctly, right? As mentioned earlier, the more you mix things, the more difficult it becomes to actually manage this and get it right. And it requires JavaScript and C# parts, which, of course, you could argue Blazor requires, but this also requires you to know about it. So it definitely is more for the experienced web developers. Again, since this is such an important one, when microfrontend started, a lot of people were blogging about them, and the blogs always were just focusing on one point. Now you can use multiple technologies in the front end. Don't follow that approach. It's really nice to to showcase something, and so I'm also guilty of that. But this should not be the number one reason to do micro frontends, and it should also not be the number one reason why you should do it. So always think about the less is more, less frameworks to use. So this is otherwise the death of performance. If you just have 5 components and they are using 5 different frameworks, you still need to load 5 different frameworks. It's not good. Okay, great. So just to bring that with all that we heard in the first section of the talk into alignment, this really follows the development approach that we've seen. So you can now have this additional area where you cut your front-end development efforts. You could now, for instance, say, hey, I create real full-stack teams for my billing domain, right? So the same persons that are responsible for the service are now responsible to bring this to the front end. And I have maybe a dedicated team to take care of the shell. It doesn't need to be like that. You can cut it in any area. You can also say, I still have my backend teams and I still have the front-end teams. And you can actually use that freedom to make the best decision regarding cutting of teams, regarding development of your application. This is where I see the great benefit of micro frontends. It's in this freedom to actually allocate resources to the maximum. So one thing that now might help you to achieve this JavaScript distributed approach that we've seen is a framework called Parse. I'm also maintaining it. And what I want to show you is how that might look like. So here you see a web application that just starts immediately, right? But it loads Blazor, and if you had a closer look, this counter button there, it just appeared. So that was actually coming from Blazor, and if you click there, the whole content is also from Blazor. So you have a whole web application that's not Blazor, but it loads the things from Blazor, and when they are there, it can show these things, right? But it's not really bound. And that's the great thing. So as mentioned, you can do this lazy loading now, and you can do the side-by-side thing where all the content we've seen here, all the text here is pretty much coming from some JavaScript-driven framework, but then the counter and the content of the counter page, that's coming from Blazor. How does that work if you want to develop against it? there are two sides. One is the developer of the modules. The modules are here called pilots. Here you would use a tooling called the Parse CLI. That's a simple command line tooling. It helps you to build, debug, and publish modules. And with that, the module developer has pretty much everything at hand. The rest depends on the framework being used. So for Blazor, of course, you would use .NET and the .NET CLI and all that, right? Now, for the end users, they will always get a consistent experience, a consistent application. This application consists of two parts. One is an app shell that's called here the Parallel instance, so that needs to be created. And the other part are the different modules, so here called pilots. And these are also, of course, created by the module developers, but they are delivered from a CDN usually, joined working with a feed service. So this feed service is actually the whole glue in between, because it tells the app shell what microfrontends to load. And that's quite good, because we could use anything to actually make the decision, right? We could use a static JSON, and actually Pyrrole doesn't care. It could be a static JSON too. But if it's a feed service, then first of all, deployments and rollbacks are going way easier, because this service now manages who can deploy, who can roll back, what versions have been deployed in the past. But it also can now manage rules which, let's say, define if a microfrontend should be loaded or not. And this is quite good, because it allows us to compose an application on the fly. I will show you that in a few seconds. Right, and so what we end up with is a lifecycle as depicted here. You start with the development of your app shell, you put in the basic design elements, whatever you envision your application in, and at some point you say, I'm ready now for my first modules to go in. And so you start module development, and you continue also when your application shell is already deployed. So then at this point in time, you're fully decoupled, and you just continue and release new versions of your modules. And of course, you can start new modules anytime, and they have completely independent life cycles. So all this, what we wanted in the beginning, independent teams that can make their own decisions, this is given using this approach. As an example, let's look at a website most people are familiar with, which is called Netflix. So it's a video streaming service. And of course, if you enter their web application, what you're mostly interested in is seeing what kind of TV shows and movies you can watch, get a preview of them, and of course, watch them. There might be other functionality. A search would be important, right? So you have something in your mind, you want to look for it, if it's there, and watch it then. And of course, you might want to have something like a watch list. We call it your favorites, and you want to bookmark certain things to watch it then later. So you can already, let's say, make a domain decomposition of this video streaming service and say, we got different areas. We got here, for instance, a browse area that should aggregate all the movies. So this is like a dashboard then. We want to have search, favorites, profile, and maybe everything that has to do with previewing and watching. We also want to do it in a subdomain here. Right, so if we now, let's say, want to follow this approach and just have a look how scaffolding, so creating a new module might look like, let's have a look here. So just a quick run through, we'll do that all live now, also in a couple of seconds, but just to show you, you can do everything via the command line using npm init, so you need the whole Node.js npm stack. What you would need to tell it is create a new pilot, and also what would be the application shell for it. Here it's called Smapyot Netflix Parallel Demo. This team chooses ESBuild as a bundler. So if they start debugging, what they end up with is this. It's just an empty shell of this Netflix application. Why empty? Well, because that's just the shell, right? So there is nothing in there at this point in time. But the team could load more pilots. So they could say, well, bring me in all the microfrontends. And suddenly the application transforms, and you see here, voila, microfrontends are there. Great. Now you can play around with it. You could disable micro frontends, enable some, add some new micro frontends, and see how this whole thing looks like. As you can see, you can also visualize where the different components come from. So this is what you get out of the box via the tooling here, a browser extension of the Parse framework. Again, it just gets all the information from these micro frontends, what is rendered at the moment, and how does it look like. All right. So how can we now extend this using, for instance, Blazor? Let me show you first the sample application. So here we are in a view called the feed service. Now in the feed service, we have our feed, and the feed actually contains all these micro frontends, right? So you see here, we got actually quite a few of these micro frontends in there. There might be rules behind it, but yeah, we don't care at this point in time, just to see what is actually listed here. Now, keep that in mind. We now go into the view of developing our own pilot. So beforehand, we've just seen how a pilot might be scaffolded. This is now the VS Code view of the sources of a pilot that I scaffolded using Blazor. So here we got a C# project. So it's using .NET 7. It also uses this shell that we've seen before. So the SmartPiot Netflix Parallel Demo shell. And it uses a couple of dependencies. So these are just for tooling purposes. So we got here a dev server, not using that since I'm just using VS Code. Don't want to use that right now. I got the standard tools, so that helps me for building, and I got the utility package. So here are some shared components already from the core framework. And with that being said, of course, I can now have something like a counter component. The other thing I wanted to show is we don't have a program CS in here. You would usually have this, but I mean, keep in mind, we are not developing here a full application. We're just developing a module, right? So this was replaced by a module CS. We still got an entry point here, but it should remain empty because there's nothing to be done. And if we want to, for instance, configure dependency injection here, we have a configure services function that we can just export, and it would be picked up if we define anything in here. So we can still define all that. Right. And with that being said, I think the server is already running. Let's have a look at localhost 1234. And here we are. So this is essentially what we've seen beforehand. This is completely empty at this point in time. And what I can now do is I can go into this Parallel Inspector, which is just a browser extension here for Firefox, but it also exists for Edge and Chrome and whatnot. So using here the Add Pilots feature, I can now just bring in all the existing pilots that we see here. So all I would need to know is the URL, this for instance, right? And if I do that, then we get all the things coming in, and the full application assembles in front of us, right? And so we already have the favorites, so we can also change our profile, for instance, and log in, and we see essentially the things that we've seen beforehand. So what's behind this URL? Well, it also can render as a nice screen, but what it is actually is just some JSON, right? And this JSON contains now information about the used microfrontend. So here we see, for instance, there's a pilot browse microfrontend being used, or here's favorites, right? Now, I could, of course, turn off favorites. So I just disabled that. And if I now would refresh here, you see that favorites is no longer here, right? There is no favorites. Here, of course, we loaded the page earlier, but let's say we redo the whole process, add it again. You end up without favorites here, right? It's no longer in this list. It's completely gone, right? So again, let me enable it. Reload this. It's empty, of course, because that's just the emulator. And what we get here is favorites again. And there's one important part about the modeling of this, right? So these pilots, they are micro frontend, and a micro frontend comes with several components, potentially several components. So here what it comes with is one component for the favorites menu link and another for this page. And then even some more components for here this button and here this heart, for instance. So if the favorites microphone is disabled, it will also remove all these components. And that's a consistent story, because you don't want to have the link but have no page, or have the page but there's no link to go to the page. You also don't want to have the button but there is no functionality behind. So there shouldn't be any ifs or so in some of these microphonents, and that's again where this loose coupling shines. If there would be the strong coupling, you would be doomed again, because how do you now control this, that this thing can be there or not? So now let me just disable that, and you see it really consistently flows away. So no more favorites here, no more here, no more here, just gone. Okay, so how does the counter now come up? Well, I mean, the counter is at the moment as its own page. So we just go to counter, and here it is. It has current count 0, and you can just click it. So far so good. There's a little bit more in it. I also used here a extension called the Parallel extension, and this one should go to movie tile. We don't see it at this point in time because it's not loaded. It just comes from other components, so from our list. So if we add this here, you see not only did now the menu get populated, we also see that suddenly we have here some tile and a heart, right? So we suddenly have something appearing here, but this something that appears here, that was not really defined in our counter page. It was just defined somewhere else. All we did is we have this extension that we marked, right? And we gave it the name movie tile. It's the name that was already used by some other microphone to register this component, right? Again, you see it here. We use this movie tile, and the Parallel extension is here. We can then just provide some props. We do that in this case via JSON. There are other ways, but that was the most simplistic one for this demo. Right, so that being said, you can easily just npm run build to make the whole package releasable, or just .NET build to refresh here the example. So as I could, for instance, just go ahead and say, hey, let's maybe use a different color. I don't know, color red. I just .NET build and hope that the demo gods are with me. But if everything's all right, let's wait for this to be finished. Should be fine. And here you can already see that it's now red. Didn't need to reload or anything. It just does all that automatically for me. Okay, so that being said, this is how you could go on. The project is called Parallel Blazor. You will find it on GitHub. Also there you will find many other links. So what you can do generally with Blazor, also independent of Parallel. And yeah, also happy to answer all the possible questions that now have come up. I want to give a little bit of a summary. We started out with a generic microfrontend architecture. Why we need then to go some kind of a route that we decide. Remember that it's not in a vacuum. You need to have especially a solution for how do components from non-microfrontend show up in other microfrontends. This is a crucial part of any kind of implementation of microfrontends. Then we went on to see how that works now with Blazor. Remember that we can start with a full Blazor approach using RCLs, but there are other ways too. And then we ended up with quite a generic mode using a framework for modular frontends. In this case, we had a look at Pyrel, but there are other frameworks out there too. Most of them have no direct support for Blazor, but it doesn't mean that it doesn't work with Blazor. It's always just that with Blazor, you have this additional barrier of the WebAssembly bridge, and Blazor on its own wasn't really designed with microfrontends in mind. But these days, actually, there are quite some nice features, especially custom element support in Blazor is really nice. So there are ways you can deal with, but you, of course, need to make sure that it fits your whole application and your whole architecture that you envisioned for your application. With all that in mind, thanks for your attention. Now happy to receive any kind of question, and always reach out to me if you want to know more about microfrontends or .NET, C#, Blazor in general. Thanks a lot.
Hello again, Florian, and thank you a lot for the awesome talk. It was really, really interesting. I enjoyed it. And maybe since you mentioned the GitHub project, maybe you want to send us the direct link in the private chat, and we can post it in the chat.
Yeah.
So I think that way it's a bit easier for the audience to
definitely
find it. All right, thanks for that. And then I would say, as we have still some minutes left, let's jump into a quick Q&A. And Florian, maybe to you, I would be interested in your developer journey. Like, how did you become interested in tech first? How did it started out, and how did you get to the point where you are now?
Yeah, okay. So, I mean, it started already pretty early, I would say, because, I mean, from my earliest youth on, I was really interested in computers and stuff, I would say, mostly, of course, into the gaming side. And what I always wanted is a console. My parents were, let's say, not keen on that idea. So instead, what they gave me was an Amiga 500. At that time, I would say already outdated, maybe a little bit at least, but it had two cool things. One is cool games, so that was good. But second, it also had Amiga DOS and really a lot of great development tools in there. And so I started with Amiga Basic, and from there on, when I had my first PC, I continued with Standard Basic, then C, then started with websites, HTML, Perl, went over to PHP, had the full spectrum. So I was always then, from this point on, more and more coming into the programming side. Not so much web. I mean, web was always cool for me when it started out, and having our first website online there in the mid of the 90s was kind of a cool vibe. But later on it all became all about applications, IoT, and then back to the web in the last 10 years, I would say, starting with HTML5, and never looked back. So always very happy on that track. Yeah.
So as so often, it started with gaming, and then it was like, through your interest, a very organic journey for you. And now
very organic, just fit. That just became for me apparent that is a good fit of let's say how my brain works. So other things are not so easy for me, but programming always. People always say I have a compiler in my mind. I don't know. It just felt natural, so I always continued there. It was awesome. Just a nice journey.
So you were born at the right time in the right place. Perfect. All right. Going on from all the knowledge you have, maybe you can answer some of the community questions as well. First one would be, is using Blazor for micro frontends the best practice?
As usual, the answer is it depends. It depends on your project, depends on the background, right? So I would say, so maybe a few claims in the beginning. If you can do your web application with a monolith, do it with a monolith. So if it's just a small thing and you have a small team, there's nothing better than a monolith. You can just control it, you ship it out, it's good. Of course, if your project grows and grows, and this talk is tailored or is meant for these large projects, and micro frontends become, in my opinion, not only one option, they're usually the option to go to, so really the best one. And now it really depends what do you want to have now as your technology mixture, right? To feed in your micro front ends. And if you already invested heavily in Blazor or any kind of Microsoft stack, then yes, I mean, the answer is definitely yes. If you're already at some other stack, I wouldn't go over, right? But that always depends, of course. So who are the people in those teams you want to embrace, you want to has as participants of your project, and how is your project set up? So there is no silver bullet here, right? I wouldn't say yes, but I also wouldn't say no. It depends, like many things in technology.
You can believe me, when we get questions, normally the first and last sentence of the answer is it depends. So, but you really well described also the dependencies. So I think everything should be clear now. And we can go on to the next question. Which framework do you prefer to implement a micro frontend with using Blazor? Vue, Angular, or React?
So personally, I'm a React guy. I can also see benefits with Vue, for instance. It's very lightweight. In general, the frameworks that are more lightweight are better for micro frontends than the ones that are not. So for instance, Solid.js or Svelte are some of the frameworks I like the most, even though I'm not using them actively. I mean, I'm using them partially, I would say, but they are not my primary frameworks. But I always advertise it to, if you want to make a micro frontend, if you're really, let's say, free of any technology, choose one of those, because these are frameworks that they have a very, very low footprint. They are really, really fast in performance, and they are, in my opinion, also easy to work with. So they're ideal for essentially such smaller pieces where you say, I'm not sure, do I maintain it in the future? Do I maintain it now? I don't want now to make this technology choice also a choice for everything else. They're ideal for this case. If you already, of course, know that, this is a technology that now everyone should use. Again, I'm a React guy, but I can also see, for instance, Angular being a good fit here, right? So it all depends, again, on a little bit of the background of the engineers you work with and what's also your future outline here, what you have in mind.
But thanks for that answer as well, Florian. We got another question. How can I convert existing web app monolith introducing approach like Pyril with new models in different technologies?
Yeah, so I mean, there are different ways here too. Depends. The best way is, of course, always to start something new. The second best way is if your existing approach already is kind of, let's say, modular, but of course, it's still a large application. But to get out the chunks that you need to refactor that maybe. So, for instance, if that is already a React web application, quite often it's very easy since it's component based. So it's why there might be still some dependencies on, let's say, global context, etc. Quite often it's very easy to refactor. The third approach is you can use something that is also very known from microservices. There's a strangler pattern, so you can always use, for instance, an iframe that also works. Why I'm usually quite hesitant there is, I mean, while that works, it's a very nice isolation barrier, an iframe. It also comes, of course, with drawbacks. First is doing, let's say, integrating an iframe nicely, that it, scales and all that, really presents itself well on the screen, is more complicated than when one might think. And the second is you still would need, of course, this legacy application to, let's say, embed nicely. And quite often the legacy application also has a footer, a menu, whatnot, right? And you would still need to tailor that, right? So therefore, quite often one of the first two approaches that I mentioned are better. But yeah, I understand it. It's a very often used concern. So how can I now migrate? And again, I would say first look at what you have. Can you already follow maybe a second approach, or is it even small enough for the first approach? Maybe go for the third one. There's a fourth one I want to mention, not migrating at all, right? Or putting that maybe still in an iframe, but inside of a model dialog or something. It really depends on the application, how it should present itself. Yeah, you would need to see how big is that, what transformation options exist, and then follow that. But strangler pattern is something that you might want to consider here or look up for that.
Right. Thanks for giving insights into this as well, Florian. Before we talked a bit, or you talked a bit about IoT, are you an expert when it comes to IoT? And maybe if you are, you can share with us what is maybe the next big thing.
I mean, I left that space around now it's 7 years already. So I'm not sure what the next big thing here is. It's always about, or it was at least, and when I have my ears a little bit open, of course, I still hear it. It's always about unification of protocols. So one thing where IoT really, at least until now, failed, and I don't see that actually also happening in the future, but people are still hoping, is a unification of protocols, for instance. So we got always this famous XKCD comic where they say, oh, there are now 17 standards. Let's make a standard to bring them all together. And the next picture then shows there are 18 standards right now. So that's a little bit the story of IoT. So you've got a lot of different protocols, a lot of different standards for communication on whatever OSI layer you might want to think of. And always when people talk about something, may it now be thread or maybe some other protocol, they always say this will be it. And then it's just another standard too. So yeah, I think this unification, I still hope it comes at some point in time. The only thing I see is that, for instance, Zigbee, in my opinion, proved to be the standard for instance, everything that has to do with light, and the rest still to be determined. And so I think this might be a good example to look at and say, well, this we might now get these let's say, protocols for dedicated areas at least, instead of having also in some areas these kind of multiple standards. But yeah. I wouldn't call myself an expert since I'm 7 years out of the game there. I'm just witnessing what's all to be done. And it's a very, very nice area to be working in, my opinion.
Yeah, but you're still interested in it, as it seems. So thank you so much for this insight as well. And Florian, thank you so much for your talk, for the Q&A. It was really nice having you. It was a blast. And hopefully see you at the next live day. Have a nice rest of the day, Florian. Bye.
Thanks for having me. Bye.
Okay, real quick, before we jump into a 20-second break, since some people are posting questions in the chat, it's a bit easier for us to monitor them if you're using the Ask button, so please keep that in mind. And now, before we go on to the next speaker of the day, just a 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to .NET and the next speaker of the day. He is developer and president at DDsoft. He's also a Microsoft MVP. And he invented technical solutions and systems to help people with disabilities. Welcome, Danny.
Hello, welcome, Benedict. Thanks for inviting me doing my talk today at this awesome .NET Day of WeAreDevelopers.
Thank you so much for joining, Danny. Really, really nice to have you. So before we start with the talk, would you mind sharing with us what we are going to learn from you today?
Yeah, so I want to go back to Florian's talk to say something. I love the talk. And he showed us great stuff with Blazor, and I love Blazor. And today I will show if you make front ends, and this can be micro front ends, but it can also be monolith front ends, how to make it accessible for people in the world with disabilities. I'm going to start to teach the attendees a little bit about disabilities, because lots of speakers are nice IT people, but lots of developers are nice of IT people, but don't know a lot of stuff about people with accessibility or with disabilities and with special needs in our environment. I will talk a little bit about those. Then I will talk what they need, and I go back to some standards that exist for accessibility. And of course, we're going to integrate them into a Blazor solution today.
All right. So very important talk you have prepared for us today, Danny. Then I don't want to steal any more of your precious talking time. And I would say, without further ado, stage is all yours, Danny.
Thank you very much. I just set my timer that everything is okay. So welcome to my talk, Blazing Accessibility Basics. Today for the WeAreDevelopers.net live day or live day about .NET. So let's start with introducing the topic, because if I make slides, I want to make the slides accessible too. And just starting with a good structure with introduction, also showing with content people can expect and what they can't expect. In fact, accessibility is a part of accessibility. So after the intro, we're going to talk about what is accessibility and inclusion. And you will see that those two words, or those two terms, go hand in hand. Going as I teach in the introduction conversation, there are standards, and one of the standards for accessibility is the POR principles. So I will start with introducing the POR principles. And PORs come from perceivable, operable, understandable, and robust. So we're going to implement those four in our Blazor applications. And there will be some time to thank you to attend this talk and for questions of you. So I'm Denis de Klerk. I am president, also IT coach, developer at DDsoft. IT coaching is a methodology that we are developing ourselves at DDsoft. And DDsoft is a non-profit in Belgium that connects the IT industry and the social industry. So we help IT companies with social insights and knowledge, and we help social organizations with IT knowledge and IT insights. I'm very proud that I'm a Microsoft MVP, and this week is a very special week. Just before next week is a more special week. I am inventor of the hashtag Beaming as Believing, and you are kind of geek if you start to print this stuff on your own clothes. Yeah, I'm that kind of. And I'm very active on Twitter with this hashtag and also with my Twitter handle at Denny de Klerk. And you can always tag me if you love it. If you hate it, do it in private. If you love it, do it in public. So start about what is accessibility and inclusion. So accessibility, in fact, means that people with all needs, and if we speak about all needs, that means normal and special needs, can access the internet, can access daily life activities. In fact, they can access all areas. In fact, accessibility, the term accessibility is already invented years before we had a computer and internet. Then it was all about physical accessibility. For example, wheelchair users should also be able to go into buildings, into stations. So accessibility is not internet or computer born. It's something that exists already, how to include people in the life, and is adapted now into the digital world we are living in today. And accessibility comes hand in hand with inclusion. And accessibility is really making the stuff, though today we're going to talk digital stuff, Blazor applications. Accessibility is about making the stuff accessible for all those people. And inclusion is more a vision above that, that say we really want to live in an inclusive world where all people participate on the way they are participating on the best way. And even Microsoft invented for that an own design series. Microsoft has a few of this, a lot of design guidelines. For example, also about reactive design and not like reactive, responsible design. Yeah, there are some designs, material design, but they also have a very specific design guidelines principle for to include people with disabilities. And they had a statement, inclusive design is a methodology born out of digital environments that enables and draws on the full range of human diversity. Most importantly, this means including and learning from people with a range of perspective. Also listening to these people, learning from them. It's not also, I am the expert, I am the ITer, this is accessible, this should work. An expert also listens. It's really, does this work for you? And what can we do better? Learning from those people. And they are describing three major steps in this. First, recognize inclusion. Just recognize that your application, for example, at this point, without adapting inclusive stuff, excluded some people. And then you need to solve the problem for one specific persona or person, and then extend to as many as possible. And as I said, we also want to learn about those people. At the bottom of the slide, I have the link to the official Microsoft Inclusive Design. And one of the stuff they use is the persona spectrum, and I love that kind of spectrum. So you see 4 categories of what people are able to do, and three categories of the situation they are. For example, it can be permanent, temporary, and situational. And what I really love about including this persona spectrum and the inclusive design guideline, that it really destigmatize people with disabilities. In the past, it was more stigmatized. For example, they put a new parent, so with a toddler on their hand or a baby, not a toddler, a baby, it can be both, on the hand, they put that in the same spectrum of a person who is paralyzed or has only one arm. I love that thing. I call it normalization disabilities. Same of a distracted driving, putting together with a blind person. I don't say you should work on while you are driving on your Blazor applications or consume them too much, but you know the concept where we're talking about and what I love. There are little, yeah, let's say there are exceptions what you not should do if you drive, by example. But you see the point. It's really about all those people have sometimes disabilities, so they are at this time this or less able to do stuff that they would do if they didn't have that situation. I love that. But that was about Microsoft, and I want to add this Microsoft stuff in my talk because it's about Blazor. But there is also something else, and that's the worldwide accessibility web content accessibility guidelines from the Web Accessibility Initiative provided by the W3C. So that is the guidelines really about accessible web, and that is really technology independent. So the Web Content Accessibility Guidelines is developed through the World W3C process in cooperation with individuals and organizations around the world, with a goal of providing a single shared standard for web content accessibility that meets the needs of individuals, organizations, and governments internationally. So there's a consortium, and the funny thing is, this was really since the beginning of the Worldwide Web Consortium. They already had the accessibility initiative. It's amazing. And as I said, there are some guidelines, and you can also call it a framework, in fact, these days, but then a tool framework, not a technology framework. Or yeah. So there's the 4 principles. And also, again, we have the link at the bottom where you can see way more about the 4 principles, because there are a lot if you really go deep into the details. And I only have about 45 minutes to talk a bit about Blazor and accessibility. I will not add all the principles in our demo application because time-wise it's not possible. But does it mean that the guidelines who are not included are less important? It's just time, or choosing of what interests me most and what's more handleable in the demo application. It's nothing more than that. And also, of course, if you develop accessible websites, so if you develop apps, websites, web apps, I want to be that they are accessible. You need to test it, just like we have unit testing to test our code and different parts of the code and the database, and even integration testing. There are tools that you can test on accessibility. This tool that we're going to talk about today is a Microsoft Accessibility Insight. And that tool is really testing against the poor validations of the World Wide Web Consortium. And that's amazing. So really against the poor principles from the World Web Content Accessibility Guidelines. And you also can see your score, and it can even say what you should do better. So let's spin this off with a little demo about accessibility insights. Now I'm going to do something really strange. I'm going to copy this URI. And it's production and development, and also just for consuming. And let's say you only need to install what you need and not install everything on each version of the browser. It would not make sense. So, and here I have installed that all. So the accessibility insights for web is just a plugin that you can install in any browser. No, I love Microsoft Edge, but it can be in Chrome. I think it also can be in Firefox. So I open the panel and I can do some tests. I can go back to the Launch tab example, and I can start with a fast pass. I see normally a little error. That's the view poke. To be honest, that's one that wasn't there before a specific update, and it's not fixed yet, to be honest. But that has to do with about scrolling. But the good thing is, even there is a little viewport error, scrolling works. I will talk more about the disappearing of the menu later on today. In this talk. Okay. And I can also show top stops, but you will see that later today. So this tool has really a suite of things to test your application. But as you will see, we will talk about that later. So this tool is to test the application to look if it's accessible as if you want. Okay. So the Parse principle. The Parse principles. So the Parse principles come from perceivable, operable, understandable, and robust. So perceivable means, can everyone access the content on the website or the web app? Operable means, can everyone operate the website or the web app? Understandable means, can everybody understand the content? And robust, if the application is robust, is everything working well and fluid? And I think today there are a lot of non-native English speakers, and for those it can be confusing. What's the difference between all of stuff? What is the difference between perceivable and operable, understandable? So while perceivable means that everyone can access the content with different tools, understandable means that everyone should be able to understand the content. So you can perceive, you can get the content. So if the content, just make an example for people also without disabilities, let's imagine that there's a language that you are not capable of. For example, if I consume a Spanish website, I can't speak Spanish. I can perceive all the characters. I can, as my eyes, perceive all the content on the website, but I will not have any clue what is the website all about because I cannot understand. But that's really important, different, because perceivable, let's imagine that I am blind and I don't have a screen reader, or the application does not work with my screen reader, I even cannot perceive it. I even cannot get the tokens and the words and the language in the language that I don't understand. So this separation is really important. So how do we make perceivable Blazor apps? So one of the most important things, and we come back to the people with vision loss or blindness, that there's text alternatives for non-text. So we all know, we all should know in HTML, you should provide alternative text, so alt text for images. And what has this to do to Blazor? If you make a Blazor application, most of the time we'll work with a data set and a model. So you need to think about adding an alt description and the model if you are adding pictures. So if I, in my application, adding pictures about conferences or about slides and the model, I also should provide the field for the alternative descriptions in the model. Content can be presented in different ways. That's quite easy day of today because we have the good, well-known HTML5 standards there at this time for a while. And we also have modern UI frameworks. With UI frameworks, I don't mean SPR frameworks like Blazor, Angular, Vue. I mean really the CSS frameworks. For example, Blazor can work with Bootstrap.css. There's also Tailwind.css. So if you combine HTML5 with a decent, quite recent UI framework like a Bootstrap, like a Tailwind, that should already do a lot of the stuff. Fonts and clear fonts. First, two things. It's really important that your text is big enough. So your font size, so the text font size, should be big enough. And please use the standards. Use well-known fonts. Don't do some really, really esoteric or really, really crazy font that looks nice for you. Okay, maybe it looks nice for you because your eyes and your mind is perfectly able, but some fonts are so confusing. For example, people with vision loss, but also people with dyslexia. That's a neurodiversity, something in the brain. It makes it so more difficult. So stick to the standards for the fonts. And I don't say you all should code in Comic Sans MS, but there's something funny about Comic Sans MS, and I don't use it because it is hated by the web designers community. But I read lots of documents because that is a font that's really good for people with dyslexia. It's one of the most accessible fonts. So you can say that the really fully abled people who decide the web standards and the web design just decide that it's not a nice font because it doesn't look good. But at this time, they say that the really accessible font is there not anymore because it's a shame to use it. Also, color. I have a full talk about color accessibility that I'm not giving today, of course. But one of the things about color that is really important, that is not the only way of conveying information. So if you use error items, you can color it red, of course, you can do it, but not as only way. Also provide an at risk. Some people saying, no, it's not professional, it's not nice, it's not needed. Okay, maybe not if you are fully able body, but it's so much easier if you are colorblind to see that's at risk. That's kind of a rule. Show an exclamation when there's danger, and also use works as the lead confirm. Let's imagine making a great UI, of course in Blazor today, and you are using a red and a green button only because without words on it. Only it's obvious that the red button is okay. It's not okay, of course. It depends, of course. Some parts of the world that is good and not bad. It's really interesting. So also not only accessible for people with disabilities, but accessible for all people in the world. A good example. There's a region in the world or some region that red is perfect and good and green is not okay. So also for this reason, combine the colors with words like okay, cancel, it's good, it's not good. Your application should be resizable up to 400%. So in Bootstrap, so I'm using Bootstrap and I'm not a Bootstrap expert. I know Blazor really well, I know accessibility really well, but the whole Bootstrap is not my nice cake to eat. So if you scroll up more than a certain percentage, I think it's about 300 on my screen, then the menu becomes invisible. So how did I fix it? I added a footer menu. So in Blazor, I added a footer component, and then of course I also did some footer styling in the CSS file. And also the images are resizable. Also here there's a really easy way of hacking this. That is just making that your images are bigger than they should be displayed. For example, you make your application and you know that there should be images of 150 times 300, just do a multiple of that. And then of course do the resizing. For example, make it looking 150 mark 2 times 300 via CSS. So how do we make this stuff perceivable? So we have our application, and we are going to scroll. So we are at 300. As I said, you need to go up to 400. The menu as a way, is that a problem? In fact, not, because the menu is exactly the same at the bottom, just with another place, and it's exactly the same links. So here we are on the bottom. No, I'm going scrolling out a little bit just to make it easier for us. You also see we have alternative text. So if I go to you will see that there's text for you. So there's an alternative text. So how we're doing this in Blazor, I open my Visual Studio, and I'm going to start with the model because this is all about the talks. So in the talks, we have our model, talks.cs, and we have so the first slide URI, and this demo URI just points to it's based on a storage host, so a storage hosting, blob storage in Azure, so blob storage. But I also have the alternative text in the model, and then I have my components. By example, my components. So I'm going to my talk list item, and you will see that I have my. I go to the model and I say my alt text. So here I combine with the basic syntax in Blazor. I combine HTML and some C# components. Here not really a lot of C#, but I escape this to going to my Blazor model, to my model with the @ sign. So here I have talk.firstLight alternative text, and of course I have other stuff here. So how does it work? I have my talk page. My talk page has my talk list. So, and the talk list component. So my talk list, I loop to all the talks, and then I have my talk list item I just showing with the alternative text. So this is a way of making it perceivable for everyone. So it should also be operable, as you saw in the POR principles. For operable, it's important that the functionality is also available from a keyboard. So you should be able to control the whole application with your keyboard without the mouse. So in HTML, it's important that you use headings because headings is used for keyboard functionality in screen readers. And you need to be aware of a good structure of your application, really important. So in Blazor, the forms, you can work with the edit form, so between the form and edit form tags, and also the order of components. So if you're making Blazor components, these are cascading. So for example, you have your page, for example, talks page, then you have your talks list. So there's the first cascading. So the heading on my, I should think about, in my heading 1 is on talks page, maybe the talk list is a heading 2, and maybe no, and this in my talk I don't have a heading, but if I should have a heading, it should be heading 3. So you should think about the cascading of your components in Blazor. That's something forgotten sometimes, I saw. It's also very important that your users have enough time to read the content. So it's not in the demo, but if you want to, so first thing that is in the demo, that is avoid timer. So I didn't use a form that you have only a certain time to submit. But sometimes you really need timers. Let's imagine you are making a booking page, for example, for an awesome conference. There are awesome conferences in the world, and you want to have a booking time, and maybe you a booking page, and filling in the form, you don't want that they start the computer for the pre-sales of the conference in the morning and just log in when they're going home, using it when they are home, because then you are spoiling all the bandwidth and just you are disabling other people with good intent to book the tickets, the same as festivals, concerts, Rammstein concerts. So sometimes you need to have timers, but then it's really important to the eyes of accessibility that there's a button, an option to extend the time. So let's imagine you have a form, let's say just 5 minutes. It's really important that it's timed after, so 5 minutes, for example, after 4.5 minutes, you should display the option, time is running out, you can extend. If you extend it, of course, the UI should be easy to do it. You are doing two things. First of all, you are excluding those who are bots, for example, or just putting on the computer in the morning to book the tickets at night. Those one you want to exclude and you need to exclude. But you're also providing a safety option for people with, for example, mental stress or anxiety, maybe in combination with difficult brain functioning. You make it the option, okay, it's difficult to fill in the form. I can extend, I have more time, I can extend, and that will include them into your application to book the tickets. It's also very important that your content does not cause seizures and physical reactions. For example, people with epilepsy can have damages with strobe lights and light effects. Also, by example, your screen, if you are using white and black, your application, and you are switching the colors very, very fast, this can trigger an epileptical seizure, an episode. But also people be having in mental health anxiety problems or situations. If the screen is flipping too fast, it can trigger an anxiety attack, a panic attack. So if you have flashy context, try to turn it off by default and provide even a warning sentence if you turn it on. That flashy content is really, if you look, you should look it up really into the full specification. There is a term, a specific ratio that say this is flashy. If it's higher than the ratio, it's not flashy. It's only the shorter the time between the changes. So if it's high enough, it's not considered as flashy. So this movements can be. If it's really fast, try to turn it off by default. Users can easily navigate content, find content, and determine where they are. Good HTML5, but already helps a lot for tools, like example, also screen readers, also for people self-visual, but also adding breadcrumbs as a way that really make it easy for people to decide where they are in the application. Users can use different input modalities beyond the keyboard, for example, really important. But for here, the web, HTML5, and the tools does already most things for you. What do I mean? If you are, for example, screen reading software, if you are using HTML5 and people that use the assistive tools like screen readers already have that stuff. They already are able to navigate to the application. Of course, there are some things to keep in mind about your HTML structure and your component structure, but then you don't need to do very additional magic. So let's demo how to make those applications operable. and I going to the comment form. So I add a page, a comment page. I didn't demo it yet. This is a surprise for you. Then you can leave some comments on the application. First, in the comments, the first heading is a H1. Very important to know this. And then I have my in my div, so a way of a Bootstrap working with rows. I have a row with 2 columns. I have my comment list and my comment form. In my comment, I start with the comment form. It's a component, the comment form. So first of all, I have it's the client that is in a form. The heading is a H2 of the form, so the cascading of the headings. And then we have the comment list, also an H2, and then you just show the comments. You will also see, I need to show something, well, no, I just show that to start. I open my demo application. I go to comments, I scroll out a little bit, I zoom out, okay. You also will see my heading 1, heading 2, heading 2. So I can add my details. Of course, I love my own websites. Let's imagine that you don't love your own projects. I can do it fully with keyboard also. And I press tab. Okay, I can also test the tab order with the Microsoft Accessibility Insights. So for that, I can click on ad hoc tools, for example, and I do the tab stops. Then I will see a visual representation. So you see, I have an error. Awesome. So we should fix this. So it skips the first name. So let's have a look into the code, into the model. I have my, not in the model, I go into my component, I go into my comment form. Let's have a look to the first name. And what I don't have is my tab index. So I just copy this field. I don't have it in the second component I see, so I just copy this. I change this to 0. This will be 1. So I didn't add my tab index, so it's a little bit of live coding. Okay. And normally you should be able to also add it to buttons. I will save it, and I will do a hot reload. And I also will do I will test this. So I just take it because I need to do a full rebuild but so stop it to fill rebuild. That's the thing. Hot reload is unfortunately not always as good as it should be with Blazor WebAssembly, and it's also have to do with the resources on your computer. So doing virtual live streaming and building and rebuilding can be also a reason that it's going a bit slower. So it's rebuilding behind. I hope it is. And further go to my talks, to my slides, and at the end you will see if the rebuild is worked. I just check one thing, the console here. If you still see me, okay. You still see me, I go to the slides. And later on, we will demo if the bug fix, the accessibility bug fix has worked. So let's talk for the last part about not the last part, but talk about understandable apps. The text should be readable and understandable. So use easy language. Try to avoid jargon. Specifically, I should say avoid jargon on public-facing part of websites. Of course, if you are building a website for a company, and of course each company have a jargon, I should say after logging in, it's normal that you use a jargon. But in the public-facing part, it should be without jargon as much as possible. And please, if you make error messages, be descriptive in your error messages. Don't just show error, system failed, point. No, error, and try to be descriptive as possible. And in Blazor applications, so for the end user, also be descriptive as possible for end user case, so not technical. That's something developers need to learn. Be descriptive in error messages that they define to be consumed by non-technical people. Content appears and operates in predictable ways. Here, your HTML5, your headers, and the combination of headers and Blazor components is a clear example how to fix this accessibility bug of being unpredictable. People are also should help to avoid and correct mistakes. So form validation. Please use always form validation and be descriptive also in your form validation. You can even do more than form validation. You can even show already what you want from type, for example. If you think about passports, provide a way, show in the name, for example, passport number, do 2 brackets, and between the brackets say already what format you want to do. And then also, if it's wrong, say what's wrong in the error message. And of course, provide a cancel button or a clear button. Let's imagine you make a form that you only can submit, and the user is non-technical. And non-technical and also have some disabilities of mental states or neurodiversity. There's no cancel button. The person is distracted and looks, oh my God, I hope I didn't submit that form. Or I hope it is submitted, or I want to clear and I want to do it again. Yeah, a lot of IT people know we can copy the link again in the browser, fun, but it's not always that fun for some end users. So think about just cleaving the form is really, really helpful for those people. So the understandable Blazor apps. We're going to demo this very first. There's not a big demo for understandable, but I hope and I think that application, I just do one safety measure. I will do a hard refresh and a cache clear. That's ways have I learned by doing. Sometimes if you develop software, you learn the hard way. And I just go to my keyboard. Okay. I go to comments. And the bug is fixed. We start with the first name. And now I will not fill in a last name. This is really good yet. Oh, damn. I will not fill in. Test. You already see it for those submitting. So the last name is required. Yeah. And should I add a comment? Okay, it's quiet. You also see that I show it at two ways. I show it at the top, so comment text is required, and I only show it at the under the control. That's something really helps the people. And of course, we will not submit this time. We will just cancel because we don't want to have a comment right now. So that's the way you make forms accessible for those. So it also should be robust. So to make robust applications in Blazor, you will say this means, of course, again, HTML does a lot. The standards do their thing, and that is really, really good. So how do we ensure that the content is compatible with current and future users' tools? First of all, use the standards like HTML and some frameworks. Update often, but also don't update too often. And as developer, and especially if you are working for end users, the holy grail is in finding the right balance between updating often enough, but not too often. And a way that you can do it is talking to your end users, doing a disability panel, doing a neurodiversity panel, and ask them, do you have the feeling that it updates too often or that it's too slow, that it doesn't update enough? You can make a change between UI updates. We do that not often at all, but technical updates, we do it really often, but maybe some users doesn't notice even if it's a technical update. So this is really, really important. We won't do the demo again because I already did it enough. So to save time, I want to recap. I first start with explaining the importance of accessibility and inclusion. And in that part, I talked to you about people with disabilities, about Microsoft advice guidelines, and about the guidelines from the World Wide Web consortiums. These are the POR, the perceivable, operable, understandable, and robust applications. And then I showed to apply some stuff of perceivable, some stuff of operable, understandable, and robust into Blazor application. As I said before, I didn't implement the full stack of those guidelines, but I did also show you how to test this application with Microsoft Accessibility Insights. And on that way, we even discovered that there was a little bug in the navigation of my application. So it's not about being perfect, it's about continue the way to being more accessible. There should be accessible testing in your agile lifecycle. And even accessibility should be really a big part in your validation. And it should be always the website having more and more accessible, the application more and more accessible. That's something to celebrate if you achieve this. You can also mail me or book me to come to your company. I don't do shameless self-promotion here at an event, sorry for that. And via my email, and as I said, I'm quite active on Twitter with Dreaming is Believing, and my Twitter handle at Danny de Klerk. Thank you. And I have time for a conversation and questions.
Hello again, Danny. Thanks for the awesome talk. Quite interesting, really, and really important topic. I, for myself, learned a lot today, and so did the audience, I think. And we still have some time left for Q&A. So if you're ready, we can start with that right away.
I am.
And yeah, all right. And maybe also to you, I would be quite interested in your developer journey. Would you mind telling us how your interest in tech was sparked and how you handled yourself to the point where you are now?
It's a very funny story, to be honest. I am also from the neurodiversity. I am a boy, a man. I identify myself as a man. Of course, in the past, I was a boy. When I was 13, I got my autism diagnosis. And I didn't work on the computer. Very funny. My first interest was engineering electronics. And later on school, we learned for accountancy and office work. That was really boring task on the computer. And with the past interest in electronics, I changed really fast to, oh my God, I can not only work in accountancy software and office, I can build the stuff myself. And I had a friend who was a developer at that time, and I was so envying him. I was so looking up to him. And I started to learn to teach for myself since I was 16 years old, with books from the library. And I did it more and more. And then I did some evening school for adults on software development. I loved it. And then I didn't find the right job, unfortunately, due to my autism. But I became a volunteer in a center. In the past, they call it a daycare center. Now they call it a coaching center for people with learning disabilities. So people with intellectual cognition disabilities, making home software from them. So the in-house software for them. And I'm a .NET developer since all the years. And now I combine the developing and accessibility. Yeah, I love it.
All right, so you started with real self-taught knowledge and went from there. Awesome. Thanks for sharing this with us, Danny. We have some questions from the community as well. The first one would be, what accessibility features do you think are the most important? Do you have examples where huge sites missed to add a crucial feature?
Yeah, a lot. And it's crazy. It's not crazy. I should use the terminology criminal. How many sites, even from official governments and more, don't think about people with disabilities? A concrete example that I touch more and more on is just color contrast. Color contrast combination that websites make that are nice looking for a fully able person with fully perfect eyes. And yeah, but if you are even going older, so less of sight or color blindness, and also, so normally everybody should know about alt text for images. And if you look about even that, how lazy a developer can be. Or then they have some automated tool that test there needs to be alt text. And so some developers think they are very, very, very clever. I say they think. Then in the alt text, they just setting the file name again. So they have the file, the source, and then putting exactly the same in alt text. So, okay, the automatic tools say there's an alt text, but for the people with the screen reader, there's nothing at all. So basic things, color contrast, alt text. Yeah, there are things you see daily if you do a little bit of research.
Yeah. And even government websites, which should
crazy.
Yeah, they should be accessible to everyone because they provide crucial informations for
indeed
the population. Yeah. Okay. Yes, but thanks for sharing this as well, Danny. We got some more community questions. One regarding Blazor. What are the downsides and limitations of using Blazor, if there are any?
So it's always very, very difficult to answer that question because you need to be honest to the audience. And also, but I'm a very fanatic. I never had the feeling with JavaScript. And if you are autistic, some people with autism, are very rigid. I am one of those. And for me, even the little difference between JavaScript and C# for people without autism, they say it a little difference. For me, there are mountains to climb. These are big mountains to climb. So I say basic all the way. To be honest, specifically if you want to have it very, very affordable, so cheap, and you host it as WASM, as WebAssembly, the loading speed is, I think, a struggle for lots of people. There's an opportunity to do it server hosted, server vended. Then it's a lot faster, but even then it's more expensive for people. So what I really would love to see that Blazor really works even more on compiling time and the way for the WebAssembly. The other disadvantage is because it's newer, there are less third-party things like for more have already a big ecosystem. The great thing is Blazor fixed it well that you have shipped interrupt, and with JavaScript also interrupt some of those libraries. And the community ecosystem of Blazor is growing. So I hope this is
Right.
honest and full enough. Complete.
Yeah, thanks for sharing this. Also, we actually got another Blazor question. Maybe this one a bit more specific. Which features do you still miss with using Blazor, and which framework does work best for you?
I'm not missing any features though. There's one thing, I never did front-end development in JavaScript framing because I always hated it. So it's really something to do with my autism. I can say I cannot compare. It does what it does to do. For example, if I made it the front-end UI, let's say, I made it all in the past server-side to render it just in ASP.NET. It's not really front-end I really like. So I can't compare with JavaScript libraries. So it's very difficult. I just now, for that reason, I cannot really say something. But more adoption. What's really missing is more adoption from the community and more applications. That's missing.
All right. Thanks for this, Danny. Another Blazor question. I love your passion.
Today.
Yeah. I love your passion about Blazor. If you could travel back in time, would you learn another piece of tech, or would it be Blazor all the way again for you?
Definitely Blazor, because the reason is I really in the beginning when I was 16, I was a Visual Basic 6 developer when I was the age of 16. So the world of Visual Basic 6, I don't know all the ages of people watching. And I really love the way of how Visual Basic 6 developed in .NET and Visual Basic .NET and C#, also .NET language. And I love the way they are looking to things. I'm also one of the guys that started at building first desktop applications and then web applications. And I don't complain this. No, I should take the same road. Because I like the way that they think about some concepts that is different from other web technologies. I like that way. So I shouldn't have changed it. Not at all.
Yeah. So this approach worked for you, and it also shaped your mindset into what it is today. And that's a good thing.
I think we need to admit this. I think we don't talk enough about it. Lots of developers, their mind is wired, and your mind is wired by the first time you use concepts, you use technologies and concepts, and what they did to you, the emotion that you got with the first concepts. That just shapes your mind. And to be honest, I'm quite proud of how my mind is shaped in that way of thinking and developing.
Okay, yeah, that's very true. Like the first things you learn about something become core memories for the most of time. Yeah, true. We got another question. You already showed us lots of cool features and everything, but we got a question from the community. Do we have some examples for small and easy to implement accessibility features or tools to add to an existing web app website?
Yeah, I should say it's really easy, for example, to just control your heading structure. You can't imagine how many failings there also are in heading structures. Also, the color contrast, as I said before, there are lots of errors, let's say accessibility errors, of course, and color contrast. In fact, that is just teach your designers about accessibility and the importance of colors in accessibility, and let them restyle your CSS files. That is already over. And you can say, okay, bigger branding or sometimes a smaller branding with more color contrast. I think this stuff. And then about the alt text, I forgot to show one thing. In my application, I did something. I'm going to prepare some time to share my screen again to show this. For the alternative text, you can do it the hard way instead of having loads of work, by having it into your C# model. So if you do it in your model, then in fact you should rebuild all your models or redevelop, do a big update to your C# models. But what I did here is also another example, but I just didn't show it in case of time. And you always lay other priorities each time you do the same task. That's the reason you can do the same task multiple times. So here you have my components. Let's say the talk list. So what do I here? Here I have my, as I said, my alternative text talk.firstSlide.alt. For that you need to rebuild the model, and that may invoke also rebuild your backend of your solution. But if you go to my event item, I go to my event item.rising. I did a small here I had my alternative is just the event's name. The name most of the time should be in your model or something, and then I just added text to that. By example, event named logo. So you can be creative in combining an alternative text with existing part of your model. That's an example that is quicker than need to rebuild the model, and for that maybe also rebuild the backend.
All right, Danny, thank you also for sharing this, and thank you for the awesome talk. We really learned a lot from you, and thank you also for taking the time to show us like real world examples and code snippets. Really appreciate that. And yeah, all I can say is have a nice rest of the day, and I hope to see you soon on another live day.
Thank you very much.
Thanks, Danny. Bye.
Bye.
All right, and before we jump to the final talk of the day, just a 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And now to the final talk of the .NET Day, which is actually a pre-recorded talk. And Simon, the guy who sent it to us, will explain to you what it's all about. I can tell you so much. It's a project he was tinkering on for some time. Let's have a look.
Hey folks, I'll be giving you some content for the next 45 minutes or so. Now, before we start, I have to make a little admission. I'm not actually live at the moment. This is pre-recorded. As we speak, I am in a tip-top secret location which will remain forever France. My kids wanted to go and see Disneyland or something, so sure. But in any case, that just being on holiday did not stop me from providing you guys with hopefully something vaguely interesting to watch. Now, this actual talk is about one of the things I got up to during the pandemic, and I did get pretty bored and start up a whole load of different projects, including drawing. I put together the title picture you see here. It's all right. It's not brilliant, but yeah, it'll do. I'm getting better. So, the other thing I did was put together something I thought would be interesting, and that is a complete game written in functional style C#. And I'll give you the background and all those sort of details in just a second. But first, just a little about functional programming. What actually is it? So, it's a paradigm, not a framework. Now, what do I mean by that? Well, a paradigm is a style of programming. If you want a metaphor of a musical instrument like a guitar, then you can play many forms of music on that same instrument. You could play rock or pop, or if you've got absolutely no taste whatsoever, country and western, whatever. It is declarative, not imperative. Now, imperative is probably the style of coding that you taught when you first taught how to code. This is object-oriented style coding, where you are very concerned with the order of operations. You start here, then make a blank object, and then do some looping, and then at this point you add this property in, at this point you add that property in, building things up bit by bit. That is imperative style coding. Declarative is not like that. With declarative, we are more concerned with describing what we want, and some of the finer details of how are of less interest to us. So the most common form of declarative programming that most folks are familiar with is TSQL, or any other form of SQL. Because if you think about it, in an SQL statement, the order of operations is not the order that you write. The select statement is often the last thing executed, not the first. And do we care? No. What are the properties of functional code? Immutability, meaning once a variable is set, you may not change it, nor any of its properties. Basically, everything is a const with const properties. Higher order functions, meaning functions passed around either as the parameters into a function or the return type from a function. Func delegates and action delegates are exactly how we do this in C#. Expressions rather than statements. Well, an expression is any line of code that evaluates to a value, and a statement is something that doesn't. So if, while, for, those are all statements. We don't use them in functional programming. Referential transparency, meaning this is the concept of pure functions, meaning that a function given a particular set of parameters, values, will always return the same result no matter what happens, no matter anything else in the whole of the system. Given these values, you get this value back. And there should be no side effects either. Recursion, hopefully everyone is okay with recursion. If not, then see my statement previously on recursion. Pattern matching, I used to have to explain this, but basically switch expressions in C#, that's pretty much pattern matching now. Pure functional languages can take the concept even further, but pattern matching in C# is still pretty good at the moment. And it's stateless. There is no state. There's no state object that sits in the middle and gets updates. We can't change values. If anyone has used React.js, then you may have some idea of how state is handled in functional, because Redux is based on functional style coding, and state in a functional program is more like a transitive thing. It's state objects exist for a moment before they are updated by something and replaced with a new version, and so on. So there is a sort of state idea that emerges from the system, but there is no single consistent state object. And why? Why do we even want to use it? Well, for me, actually, one of the big things is reduced code noise. You write an awful lot less code, and the code that you write tends to be more meaningful in terms of what you are trying to achieve. There's a lot less of the noise of the ifs and whiles and all that actually can make it harder to understand what exactly it is that you're trying to do. And it encourages writing in a style which encourages good code design. It's more testable. If you think again on the concepts of immutability and of pure functions, then it's incredibly easy to test functional code. It's more robust, it tends to fail less, it's more predictable because we discourage or eliminate side effects, and it also supports concurrency. So if you're interested in stuff like Azure Functions, or having some sort of messaging queue set up being monitored by a whole load of processing applications running in parallel, then this all supported pretty well. It again dates back to it points back to the idea of statelessness. If there is no state, then we tend to get less in the way of resource contention and stuff like that. So if you're interested in all those sort of things, then this possibly is the sort of coding you want to look at. Now, we can't actually be purely functional in C#. It's just not going to happen. Now, it is a stated intention of the Microsoft team that it will support both paradigms going forward, and certainly every version of C# since something like C# 3 has included more functional content. And that's a process that, so far as I'm aware, is intended to carry on in perpetuity. But nevertheless, there is still issues with backwards compatibility and the like, which make it actually impossible to ever have a purely functional application in C#. And there's also a couple of features that they probably aren't going to be throwing in. So the metaphor I tend to throw around is this one, that there are roughly two parts of a shadow. Well, there are actually more, it's about 12, but there's two broad categories when you're looking at the parts of a shadow. There's the umbra and the penumbra. The umbra is the dark solid piece in the middle, designated with an A here, and the penumbra is the grey fuzzy bit around the edge. If you just look at any old shadow, you'll see exactly what I mean. And in my metaphor, the pure functional bit is the umbra, the dark bit in the middle. And this is the purely functional area of the system, where everything is written entirely according to the functional paradigm. But still, around the edges of the system, there's going to have to be places where we compromise, where for one reason or another we simply can't do pure functional code. It's just not going to happen. And but my goal is to minimize those shady areas where we compromise as much as possible and push them out to the edges of the system so that we can be as purely functional as is possible. And I'll point out a couple of areas where compromises had to be made in the course of this talk. So moving on to the background of the game that I selected, it's called Oregon Trail, and I'll be honest, I had never been to Oregon, nor until I started doing this even heard of Oregon. But there it is right there. It's up in the northwest of the US, between Washington and California. So here's some pictures I found of it. Gotta be honest, it looks lovely. It looks really nice. I don't know whether there are any international conferences that all bring speakers out to speak in Oregon, but if there are, I won't say no. If anyone's offering, it looks very nice indeed, and I'm sure it is. Nike are based there. They've got to be based somewhere. And named after the Greek goddess of victory, in case you were curious. But yep, and also the Goonies. I don't know if anybody remembers this film. It certainly was one I watched an awful lot when I was a kid. And it's set in Oregon, in an area of whichever city it is called the Goondocks, hence the name, the Goonies. And for anyone too young to have come across this one, go do check it out. It's pretty good. And finally, the legend of the Oregon Trail. That's the part of American history that this game is based on. So, as I understand it, with my rather limited knowledge of American history, this is where folks migrated from the East Coast all the way to the West Coast to set up farms or take land or whatever it was that they were going to do in these covered wagons. There's a map. So the Oregon Trail started down at the Missouri River in Illinois, and then was a sort of loose collection of trails which were joined up gradually. I think fur trappers set a lot of them up, and then finishes over on the west coast there with a pass through the mountains just towards the end. And that pass through the mountains will feature in the game. There's a picture of it. It's the only picture I could find of it, but there we go. The last stage of the journey was a mountain pass, which was the only safe way apparently through the area. And you also see hunting going on down there, the hunting for wild animals. Now, this game's entirely text-based that I converted, but nevertheless they included a hunting mini-game, and I'll leave you to ponder on how on earth that could possibly have happened, but it's quite clever the way that they managed it. And finally, there's forts dotted along the trail, where you can, in the game, you can do trading and stuff for more equipment. So let's briefly leave this bit of distant American history and then shift over to I think it's the 50s. Now, this is John Kemeny. He was a Hungarian mathematician, and I understand a very good one, although I am not myself a mathematician. I don't know if anyone's ever heard it said that Einstein wasn't very good at calculus. Well, it's him that said it. It's this guy. He worked with Einstein. He worked with Alex Feynman, the physicist, and various other people. And amongst his other achievements, he became the head of mathematics at Dartmouth University in America. And it was here that he developed an obsession with computers. He thought that computers were the way forward in terms of getting people working with maths in the university. He thought also that everyone ought to be able to have access to the computer, because bearing in mind in those days the computer was a gigantic thing the size of a basement. You would hand over a punched card to whoever operated the thing, and they would take a great big batched up bundle of these punched cards and feed them into the machine, and then hand you back the output when it was done. And this, incidentally, is where batch processing comes from. So he teamed up with a colleague at the university. There's a picture of them together. This is Thomas Kurtz, and they implemented two absolutely fantastic things on the university campus. One was time sharing. And time sharing was the idea that you had terminals dotted around the university, and the giant mega computer in the basement would share its time between each terminal, sort of flicking its attention from one to the next, and would give you the sort of impression that you were, in all of you separately, interacting with the machine, when in fact there was only one. Which meant that, amongst other things, everyone could have a go at having a play on it, which is great. And they also came up with a new programming language. Programming languages in the day tended to be things like COBOL and Fortran. Now, I had looks at some of the source code for these languages, and I can't really follow it. So they wanted something that was friendlier, something anyone could use, and it was called the Basic All-Purpose Symbolic Instruction Code, or BASIC. And elements of BASIC are still in use today. You'll possibly see some of them in the source code that's to follow. Here's a bit of BASIC. So, a couple of things of interest here. The first is that every single line had a line number. And they are going in increments of tens, because certainly on the basic machines I've worked on, I don't know how it was back in like the 60s or whatever, but on the machines I worked on, you could only either replace the line or insert a new line with a number in between two existing. So if I wanted to put an extra line in here, I'd have to perhaps put a line 15 and then start writing my code. And the next is that every single line starts after the line number. The next bit is always a verb. They wanted everything to have a verb to make it very clear what any arbitrary line of code is doing. And there we go, and then the rest of it is typically the parameters. This, incidentally, is an infinite loop, so I wouldn't recommend running this unless you want to probably ruin a machine eventually. What this will do is print a bit of text, and then line 20 is go to 10, meaning go to line 10. So this will literally just carry on printing I love functional forever and ever and ever and ever and ever. They also had an idea which back in the day was considered controversial, weirdly. And that was a keyword input. So back when computing started, it was largely considered a tool for mathematics and for doing mathematical calculations, which, is indeed what they did with it. And input kind of went against that, because with input you stop what the machine is doing and make it wait for the user to put something in and then carry on. And there were people who were resistant to that, but this is something they wanted to go ahead and include. And so the next thing happened is that everyone on campus started making computer games. Apparently there were loads of them. There were computer games based on American football and all sorts of other things. And it was all made possible because we could actually have input from the user. This is the sort of machine that these games were made on. This is a timeshare basic terminal. So notice that there is no screen. So there wasn't. This is before screens were a standard part of computing. When the print command said print, it meant it. It printed. It literally printed onto that roll of paper you can see. And you would. It's effectively a typewriter plugged into a printer with a network lead. That's what the terminal was. So moving forward again to the early 70s. These guys here, Don Rorich, Bill Heinemann and Paul Dillenberg, they were student teachers working in a university campus in Minnesota. They were teaching history. And they had the idea that they would use the computer in their university to make a game. And the idea was that the game would make it a bit more fun to learn about the subject they were teaching, which was the Oregon Trail. And that's them holding a copy of their source code there to the 1971 version of Oregon Trail, which became a massive hit on the campus. Apparently, it was very popular, and it is indeed quite a good game for considering the limitations and the time it was made. But the 1971 original version is lost when the semester ended. The memory of the computer was wiped and it was lost. But they recreated it in 1975 for the, I think it's a Minnesotan Educational Consortium. I'm not sure what the other C stands for, but and they had the idea that they could actually market this and send it around, and it as a useful educational tool. So the 1975 version does still exist, and the source code is not all that hard to find on the internet. It's shared in all sorts of sites about. So I thought this would be a fun project to convert into modern C#. This is what Oregon Trail 1975 looks like on a slightly more modern machine. I don't actually have an HP Timeshare Basic terminal, so I can only guess at how that might have looked, but this is how it looked on something slightly more modern. And it is entirely text-based. The player is prompted to enter choices, which are typically either amounts or a number corresponding to a choice, and occasionally bits of text. There are only a few places where text is used, so it's mostly integer values. There's statuses popped on the screen once in a while to show you how you're getting on, and so on. That's what a turn sequence roughly looks like. I've simplified a bit here. It is quite surprisingly complicated. So first you make your initial purchases, begin a turn. A turn consists of one or more of these things, which is go to a fort to buy things, do some hunting, or continue. You may or may not encounter riders on the track ahead, which may or may not involve a gunfight. Some events may or may not happen. Finally, we check to see whether we've reached the mountains yet. If we haven't, pass on. If we have, some special mountain events start happening as you pass through the mountains. Then finally, a mileage check to say, are we in Oregon, yes or no? If we're not, we'll loop back for another turn. If we are, then we go on to the great big ending sequence. So that's not too complicated. And this is what the beginning of the code looks like in the original BASIC. Now, the original was entirely text, 100% text, so the colours are something I've added on just to make it a bit more readable. There were no colours, it was pure text. Now, notice the rem. That is, it was an intention of the BASIC language that everything had a verb attached to it, so rem is short for remark. So even code comments, which is what these are, were verbs and commands, rather than simply being two characters, or one character depending, as they tend to be now. And then so what we're doing is a little bit of metadata in effect, and then printing, do you need instructions? Dim is instantiating an array. Excuse me. For some reason, and the concept of array and string are pretty interchangeable in BASIC, and the dollar there is pronounced string, and this indicates, in fact, that it is effectively this is a string with 5 as the maximum length. Input says take input from the player and pop it in C string, and then we're checking the contents of C string. If C string is a no, then we'll skip ahead to line 400, otherwise we'll start printing instructions. Now, with if statements in BASIC were always ended in goto, and that means that the logic is the opposite of what we're used to in the modern world. In fact, it's in the modern world, it's if thing is true, then continue into this closure. Whereas in BASIC, it was more like if this particular bit of logic is true, then skip. So when you're looking at these, you have to reverse the logic from what we probably put. So this is if no, then skip. If anything else, then write the instructions out. And it did cause me some head scratching in places to try and work out exactly what the logic was trying to achieve. And thankfully there was also an explanation of the variables at the end. For some reason it's a fairly common thing in BASIC to just have incredibly short variable names, often a single letter or something. I'm not sure why this is. It may be for the purposes of saving memory, I don't know, but thankfully they put a set of rems in there to decode the names for me, which did make life quite considerably easier. So let's talk about the process of getting input from the user. So this is one of those areas of the system where some sort of compromise is needed in terms of getting this functional, because this involves interaction with a human being, and there's nothing more impure than a human being. So how do we do this? Well, this is how an interaction with the player looks without any additional layers from us. Simply the player enters something into a terminal, which goes straight into the game. Well, I can't really do that. There's too many possible side effects. So first things first, I'll stick console into. I'll make an interface for it so that I can inject my own implementation or a test mock implementation as required. So that's a start. But we still haven't solved the fundamental problem of how do we wrap around the side effects, because anything could happen with the player, with the naughty creature. Well, there's actually three possible things that the player could do. They could enter something. They could actually enter some text. They might enter nothing and hit enter. Now, that may or may not be an error state depending on which part of the game you're in. But more often than not, that would be an invalid input if they did not enter anything. And finally, an error could occur. I'm not sure what sort of errors are possible coming out straight out of the console, but still, it could happen. So I want to be able to wrap put something around so that we can see any of those conditions happening safely. And there we go. So this is my class for wrapping those three possibilities. This is an instance of what's called a discriminated union. I'm not going to go too much into the technical terms for all of this stuff, but it's basically it's a way of capturing the idea that an object can be one of several different types. So it's a bit like Schrödinger's type. You know, if you want, you could have the type cat, but inside cat there is either a live cat or dead cat, and we won't know until we actually open that box to have a look. Well, it's the same with this. Maybe is a fairly common discriminated union type, and what maybe means is, here's a thing, there's a box here with a thing, there might be something in it, there might be nothing in it, I don't know which, but here's an envelope of type maybe. You have a look inside if you're interested to know whether it was something or nothing. If you're not interested, just pass it along as a maybe, and someone else can deal with it downstream. So I've implemented this as an abstract class, maybe of type T, so that it can have anything inside it. It's implemented first as nothing. Nothing has nothing, so there is no property. And we also implemented as something, meaning there was something in it. So now we have actually got a T property, a value. So if it was the something, there's a value inside it. Or error, meaning an error occurred. And that means instead of a value, we've got an error. And it could be one of these three different types, and I don't know which until we examine. But this is how we might consider examining it. So, well, this is how we'd return something from it. So this is a read line. A read line is reading a line of input from the user, from the player. Sorry, got to get used to that. I have had several decades of constantly saying user whenever I talk about the person that I'm supplying code for. It's taking me a bit of effort to try and remember to say player for this one. So by returning a maybe of string, I'm saying I'm giving you a string, that's what I'm intending to give you, but I don't know if it's going to work or not. So, and that's what the maybe wrapper means. So first off, everything's wrapped in a try-catch. If a hand-handled exception happens and we go into the catch, then we're returning an error out. We can examine the the result, and if it's a null or white space, we'll return a nothing, meaning that they just hit enter, or else we'll return a something, and then we'll put whatever the value is inside the something to show that we actually got a value back. There we go. Oh. There. And here's how we might consume it. So this is calling my console, the iConsole, and calling its readline, meaning that we've got a discriminated union of type maybe string, and then use a switch statement to check the type. So if it is a something, then that first switch case will hit, and in which case we can say you enter the text and actually get the text because we know it's a something because that case hit, or it's the nothing or the error, and again we can handle appropriately. This is the beauty of the switch expression that we've now got in C#. And as for dealing with something which has no return value, as in it's an operation that I simply want to execute and I don't really care if it other than that it worked, or if it did fail, then we want something to come out. So this is an alternative discriminated union I'm using called operation, either success or failure. The success is empty, just meaning it worked and I don't really care, and the failure has the error attached. And I've attached an extension method to everything, saying, okay, whenever it is, carry out the action, which is a func delegate or a function stored in a variable which has no return type. Try it out. If no errors occur, then return a success. Otherwise, if a try catch results in an exception, then return a failure. And this is how I've done my write line. Now I've had to do a for each here because I want to do a params of strings to pass to the console, just so I can save myself some effort later. And I'm not aware of any way to write a whole array in one go to the console, so a for each here is it's a compromise. But this is pushed to the back of the system, and the rest of the program doesn't need to know that there's a hidden for each here. Now, if you think about it, there's actually another layer that we have to include because, as I said, most of the time it's integers that are going to come out of this thing. So I wanted to take the concept a step further, put another layer wrapping around the something to say whether the input that we've got from the player was text or an integer, because that might be very relevant at certain points. If we're expecting an integer at some point, but they enter a non-integer, that's an error conditional. We want to capture that. So I've actually got 4 states: text, integer, empty, or error. And it is my slightly more complicated one. So I've called it a user input, and I've inherited off it a number of times. An empty input, which means they just hit enter. A text input, an integer input with the correct type on it, so we automatically got the int sorted, and an error. There's my slightly more complicated get error. So do a console.write line with a prompt, get back the result, do a switch. If it was a fail, then just return an error. Otherwise, do a read line, and then assess it. Have a look at the something. If there was a something back and int.tryparse works, then it's an integer input. If it doesn't work, it's a text input, and otherwise you've still got the error or the nothing. Wait. So here's my replacement of the user interaction, the do need instruction. So I created a user interaction class, which is what wraps all input and output requests between the player and the game engine. So I'll do a get input with an instruction with a bit of text. Do you need instructions? This will return a maybe a string, or rather it's a maybe user interaction. And I'll switch to say if it was a text input, then that means that we've got what we wanted, and I'll do a to-upper and compare it against uppercase yes. So if the user has entered a yes and it was text, that's a true. Any other condition, whether it was an error or an integer or some other text other than yes, will result in a false, and so that will tell us whether we need to display instructions or not. Next is the decision whether to display the instructions. Now this is a single line if, effectively, so I could probably live with this. It's not too bad, but you know, I wanted to see how far we could make this functional. So I wrote something called write message conditional, which just takes a boolean and based on the Boolean, it decides whether to write a message or not. So it means I can write it even smaller. And that's my entire replica of the whole first block of the game. Now, I'm going to move through this fairly rapidly. We're running short on time, so right. Get inventory. So I might skip a bit of this, but the idea is that the initial inventory has to be gotten by asking the user, the player, to give a value for each of these inventory items. How much do you want to spend on them? And then this is what the original code looks like. We're doing checks to see is it in the right range. So the oxen has to be a spend between 200 and 900, between 200 and 300. The others just have to be above 0. This is setting all the initial purchase values to 0, and then doing a series of inputs. If the player enters an invalid input, then we go back and ask again, and so on. This is the whole sequence. So try for each inventory item, see whether it's valid, give back a validation message based on whether it was valid or not, and then finally at the end add together all of the values, all of the spends that you've made on each individual. If the spend is greater than $700, then you've overspent, and we have to loop back all the way to the beginning again to ask them to do the whole sequence again. So this is how I do my. This is how you would probably have to do imperative style whiles, because that's an indefinite loop. There has to be an indefinite. Now, definite loops are easy to handle functionally with LINQ. Indefinite loops are trickier. That's a loop where we're not sure how many times we're going to go around. So what I'm doing is a while true, meaning keep looping until such time as we're happy that we've actually entered the correct values. And that's, yeah. So there must be ways functionally of dealing with this sort of situation. Well, there are some. This is using recursion. So get oxen spend is doing a check to see whether what we've decided is valid, and if it's not, then we're just calling the whole function again. And that's, if you're absolutely certain there's not going to be many calls, then this is alright. But the problem with recursion in C# is it's not optimized, and if you do too many recursion calls, you will eventually get a stack overflow. It's surprisingly easy to do when you mess with recursion. So recursion is powerful in C#, but you have to treat it with some caution. Now, F#, different story. F# has tail optimized recursion call, meaning you could do recursion and behind the scenes some magic will happen and it will handle it. Actually, if you look in the intermediate language, it's a hidden while loop, but basically. But still, in F#, in principle, you have got that, but we don't in C#. So you could do this. This would be purely functional, but I wouldn't advise it. So I've created an extension method called iterate until. And iterate until means here's a function that returns something, and keep running this function until a condition that I define in another function is met, and which is the second parameter. The first parameter there is my do a thing, which is to get an integer input from the user, and then the second is a function which validates whether this is the input we wanted or whether we should have another go. And my condition for ending here is that x is an integer input and that the integer that's supplied is between 200 and 300. If anything else happens, it will just keep running the function in the middle again and again to try and get the correct version out of the user. So how does iterate until work? Well, it's a hidden while loop. There's just no other way to do it, fundamentally. But it does at least mean that I can hide my single while loop at the back of the code base. And who knows, Microsoft might produce us something one day which we can use to replace this while with something else, and then the code becomes even more functional. But for now, there's a couple of whiles hidden way at the back, and I can live with this. It's as functional practically as I need it to be, and we're not going to have horrible performance problems. Alternatively, you can actually use a goto. Goto still exists in C#. There you go. That's how you do it. I don't think there's really much functional difference between this and the hidden while loop. I think, strictly speaking, this is very, very slightly more functional, I suppose. So, there you go. Use it whichever you like, but if you're going to start messing with go-tos, use these with some extreme caution again, because you could probably inadvertently write some absolutely bananas and hard to diagnose code. So then for the rest, it's just a get non-zero spend. So all this is doing is saying iterate until we've got an integer input which has an integer greater than 0. And since those are all the same, I just wrote one generic one where item name was the only thing that was different. And then I wrote a function which puts all of this together, which just keeps running. It's running the same function again and again, and it's got an enum which tells you which was the last item that I gathered a spend for. So whichever one it was you've just received, then go for the next one. There's my whole get initial inventory. So what you might notice here is I have actually used some recursion. There's a call to get initial inventory. This happens if you've done your overspend. I thought in this case it was justified because I think there's only so many times someone's going to go through the entire definition of all of those spends before they flip the table over and walk off in disgust. So I think it's safe enough to use here. And here is my actual game, my game engine. This is a series of calls to an extension method called continue game. Now continue game has a check inside it which says, is the game over yet? Either the player is dead. In this version, incidentally, of the Oregon Trail, you can only die of pneumonia or injuries. There is a cliche in Oregon Trail, everyone dies of dysentery. Well, it's not in the 1975 version. Or you've reached Oregon, in which case, in either of those cases, the game is over and will terminate out early. And each of those continue games has that check in. So if during, Riders on the Trail you died, then continue game knows that the two functions that follow it shouldn't be executed. So all of those checks, all of those ifs to say, is the game condition met yet or no, in which case terminate early, that's all handled in the structure of this continue game. There's only one flow of operations, and there's a little bit of logic baked into that flow. Now, this is an incredibly simplified version of roughly how a monad works, but I'm not going to go more into monads here. I have other talks on that if you're interested. This is what continue game looks like under the surface. It's very powerful, but it's not very complicated. It's just checking game state to say game over or dead. Game over has a number of meanings, and the game over check is elsewhere. If either of those is true, then simply return the unmodified state to the next call to continue game, or alternatively modify using the func which turns game state to game state, that is an old game state into a new one, and get the updated game state. Very, very quickly, this is the shooting minigame. This is how it works. So how it works is it printed type bang, took the user input, the player input, and then if they typed bang correctly, then it looked at how many seconds it took you, with a maximum of 7. And then based on how many seconds it took you to type the word bang, that determined how good a shot you had. So I created a gunshot client which replicated this. This is it. I needed a player interaction into here. I took a time service because I wanted to be able to do user test, unit testing. And I can't have a datetime.now because that's impure and I wouldn't be able to predict the results. So time service is just a way of injecting a datetime.now of my choosing. So get the current time, do a player interaction saying type bang, examine that input, see that it's text input this time, an integer would be considered, or any other state would be considered invalid, and then check it that it's the word bang, and if it is, then we can do a time check to see how many seconds with a maximum of 7. Otherwise, if they did anything else whatsoever, then they'll get the maximum, which is 7. And then finally, okay, well, we might skip the next one, the Riders on the Trail ahead, although this was another complicated set of probability checks. There was an incredibly complicated formula there to determine whether the riders appear, whether they are hostile, whether they look hostile, but aren't, and various other things. And it took me a long time staring at the code to work out exactly what this did, because the reverse logic if statements and the various levels of check, it took me a bit, but I simplified it down to are there riders with a probability check using an RND, which here is my injected version of a random number generator, because again I need to be able to do unit testing. And then to say, are there riders? If they are, do the riders encounter? Otherwise, pass on state unmodified, meaning we didn't do anything. If there are riders, then first check, do they look friendly? And then there was a complicated sort of three shell shuffle thing going on with, are they actually aggressive or not? It was based. What I simplified this down to is, do they look friendly, and are they what they seem? Meaning that you start off with either friendly or unfriendly, and then it switches based on another probability. But you have to make a choice to say what to do. And here I've simplified this down into a switch expression where were they friendly or not, and what choice did the player make? Do they can run, attack, continue, or circle wagons? And all of these have implications in terms of how many miles you did, how many bullets you've used up, and again it might be a call to the shooting minigame. And all of these have got these state updates here baked into the switch expression. And then some right conditionals based on whether they were friendly or not. And then finally it is dead check, because if you ran out of ammo at this point, you are dead. So then you'll get the dead message at the end. And then finally the end of the game. This checks to see whether you've reached the number of miles expected, and then if you have, then you get this lovely message at the end. Now this little .7 thing there is a bell. There was actually a little bell on the side of the terminal, so this actually runs something like, you ding finally arrived, ding at our ding gun, or something like that. I've heard it suggested there might be a tune being played, but I've got no idea, to be honest. But I don't know if anyone's got an old timeshare basic terminal that we can try this on. I have no idea. But still, that's the idea. Apparently there is a bell command, so I may pop this in a modified version for the now, moving on to ideas for other games that I might look at in the future. This is the very first Star Trek game. The E within the two chevrons there is the Enterprise, and you're flying around looking for Klingons to blow up, which is very in the spirit of Star Trek, I'm sure. But this game is incredibly old as well. This is about the same age as Oregon Trail, and like Oregon Trail, that means it's so old that it predates Pong. So it's the source code for this is readily available on the internet. It's a little more complicated because we actually need to update the terminal and write to particular coordinates on the terminal, so this one might be a bit of fun. There is a Doctor Who text adventure game as well, but this one is so big that the source code actually consists of compressed data, and when it moves from section to section, what it does is it uncompresses itself, then runs the code, and then decompresses the next bit and moves on, because the computers back then had very limited memory. The one I used to play on only had 48k. I think this ran on a BBC Micro. I don't know how many of those had. Zork is another text adventure I was thinking of having a play around with as well. This is a lot more complicated, and if you want to have a go at a text adventure and see a proper one, like a proper amazing text adventure, Zork is a good place to go. And the source code once again for this is available on the internet, so I might well have a go at Zork. Unless I get eaten by a group. So I'll wrap up now by saying that I have a book coming out soon. Hopefully it should be out in shops in the summer, and it's going to be published by O'Reilly. There's a URL you can scan here, and I believe that it should give you a month or two free on the O'Reilly platform if you'd like to read the early version. As of now, I think there's about 11 chapters of the book, going up to a maximum of 15, so you can read an awful lot of the content, and we're working hard now on the final push to getting this out into the shops. So there you go. Do have a look if you get a chance, and let me know what you think of it. Now I can't do any questions because I'm not live. I will be keeping an eye on Twitter while I'm away, so chances are you can reach out to me on Twitter, or I'm on LinkedIn, or anything like that, and I will try my best to answer your questions. Have a look for my website. You can see the link in the top right up there. And you'll find that I'm pretty easy to contact. So thank you very much indeed, and I hope you've enjoyed this talk, and feel free to reach out to me and say hello, like I said. Thank you.
So many thanks to Simon for the awesome talk. And hopefully next time he can join us in person. Until then, we wish him lots of fun and especially his child in Disneyland. And as he mentioned, if you got any questions, just reach out to him on his Twitter. He will gladly answer them. And now that also this live day slowly but surely comes to an end, just some quick informations for the end. Don't forget to check out the InfoBib pre-event series from our World Congress. And the World Congress you can check out by clicking the banner above the stream, which leads you to worldcongress.dev, where you can get further information and claim your tickets. And also, thanks to our amazing partners, you can check them out by scrolling down on the live page. Those logos are clickable. Click through them, leave them some love on their website, and check them out. And yeah, also to you, many thanks to the audience. Thank you so much for engaging with us today, for being the awesome community that you are, and hope to see a lot of you again on the next live day, which is Security Day on April 26th. See you soon.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.